जंतर मंतर।
अभी देखो चालू है, देखना बच्चे आवाज आ रही है? हेलो हेलो हेलो। All right, students. So I think we need to restart this session. Okay, I get it. Thank you so much, Gaurav. So let's get started once again. My name is Deependra, and let's start this video. Limits, continuity, and differentiability. Class 12th. Limits, continuity, and differentiability for ITJ. We are starting this. I think I am now clearly visible and audible. Vandana, Gaurav, everyone, give me a quick response. Thank you so much. Thank you so much. I was saying that this is a free batch. For example, we have Laksh, we have Arjuna. Those are our pad. I think there is voice, Vandana. I think I'm clearly audible now. Refresh the screen. If you cannot hear me, how will you refresh the screen? But I think I'm clearly audible now. Great, Vandana. I'm coming back to the discussion. Pay attention, everyone. I am saying that this is our free batch. Free batch here means that here you can log on to our website. You can check out the description. In the description of this video, which you can check out there, we have provided you the link of our free batch. The same link is there in the pinned comment as well. So what is the meaning of free batch? Free batch here means that you can enroll for this batch at absolutely free of cost. You don't have to pay any money, any amount. And all of these videos, which are there on YouTube for free of cost, these PDFs you can watch, you can see or download from our application by enrolling for this free of cost course. Not just that, you'll get 24/7 doubt support system as well, which means let's say you're studying at 2 o'clock at night and there you are preparing and then all of a sudden you get a doubt, but there is nobody to assist you or help you. You can get a doubt resolved, your doubt resolved, so that you don't feel stuck and you can move ahead. Yes. So all of that comes with this free batch. Link to this free batch is given in the description. Now, meanwhile, when we are conducting this session, when we are going through this live session, you will be asked a lot of questions. You'll be asked to answer a lot of questions. I'll be conducting a lot of polls. So this is how I'll be conducting a lot of polls. And if you really wish to participate in that poll, you can download our application Pylens. Pylens is an amazing platform which you can download either from Google Play Store or Chrome Store, through which you can participate in these polls and get your name featured here on the screen. It's not merely about getting your name featured. That's a very trivial, target to have in life. Rather, what's more important is you can avail a lot of benefits from that feature of Pylens. So what is that? Let's say you're watching any random video. You're watching any random video on YouTube. And from that video, let's say you want to generate short notes, mind maps, PYQs, or even a quiz and a lot more. That too at no cost with the help of Pylens. I repeat, any random video, if you're watching on YouTube and if you want to generate a lot of stuff related to that video, you can do it with the application Pylens. Are we clear on everything, students? Have you gotten a decent clarity? Shall we get started? So far in this series, we have started with the basics. I hope you do remember 12th class mathematics we are doing with these one-shots. So if you have not watched the previous sessions, we have started with relations and functions. We have covered ITF, inverse trigonometric functions as well. We have covered a lot of chapters already. I hope you must have seen. So in today's session, we are studying limits, continuity, and differentiability. So first of all, I'll start my discussion with limits. In limits, we'll understand different methods, different techniques to understand or expand the limits. We'll talk about series, we'll talk about L'Hopital rule, we'll talk about left-hand limit, right-hand limit. And then gradually from limits, we'll move towards the concept of continuity. So once you understand the concept of continuity, we'll move towards the concept of differentiability. In continuity and differentiability, we'll not merely understand what is continuity and differentiability, we'll understand them with the help of a lot of questions. And along with that, we will see that a lot of theorems through which you can solve those questions very quickly without even actually doing them the way you're asked to do them in the board examination. So shall we get started, everyone? Are you all there? If I simply get started with the concept of limit, a lot of students confuse the concept of limits with the concept of finding the value of a function at a point. No, it is not. For example, let's say here is y-axis and that's x-axis and that's your curve. This is a curve. Let's say this is how a curve is drawn. This is how a graph is drawn. So at this point A, let's say this is a point A. At this point A, the function is defined as this value, which is f of A. Now, yes, Mishra ji will be covering NCERT as well. But if you really want to prepare for specifically and dedicatedly for boards, not for JEE, then you can watch our same sessions on our PW English medium channel as well. There we are restricting it to NCERT level, CBSE level only. There we are, avoiding bringing JEE level discussion. So here it will be more oriented towards IT JEE, mains and advanced. And with this one shot, we'll cover everything. But yes, definitely, why will not we discussing Gaurav, Shubhash, short, everyone? Yes, we'll do that. And we'll be discussing all of these questions. Rather, whatever questions I have kept in this session, all are inspired from either JEE Mains or advanced previous year's questions. Good to have you, Ronak, and everyone. Good to have you all. So keep participating, keep interacting, keep answering. That's the way to stay engaged. That's a way to stay focused. Shall we resume? So I'm simply suggesting you a very simple, a very direct observation that the concept of limit says that, sir, if A is approached from its left neighborhood or right neighborhood. So this part is your neighborhood of A, left neighborhood of A. This part is the right neighborhood of A. So, sir, yes, Rudvi, this is the one shot of limits, continuity, and differentiability. Absolutely. Thank you so much for your compliment, Gaurav. I really appreciate it. Okay, Mishra ji. I hope those responses are not AI generated, Mr. Mishra ji. So getting back to our discussion here, everyone, please pay attention. I am saying that let's say if A is approached from left hand side. So if A is approached from left hand side, this function f of x approaches this value from left hand side, this value. So this will be called the left hand limit. And if A is approached from right hand side, if A is approached from right hand side, so if A is approached from right hand side, this function is approaching a value f of A. Okay, great. Good to have you all. Now, I am repeating this statement again. I am saying that f of A is a totally different thing. What does it mean? That means, sir, at A, if you're finding the value of this function, that is f of A. That is f of A. That is f of A, right? But what is left hand limit? What is right hand limit? Limit means here you're approaching this curve from the left hand side of A, and then you're noticing that f of x is going in what direction? What trend, what pattern are you seeing when x approaches A from left hand side, then f of x goes to which direction? F of x goes to what value? I repeat, let's say A is approached from right hand side on the x-axis, then f of x approaches a certain value from right hand side. So what value does it approach? What value does it move towards? What value does it try to attain? Its trend, its pattern. We try to get where is it going. We don't know at that point what could be the value. We are really not interested in that. What we are more interested in is that if x approaches A from left or right hand side, then f of x approaches what value? If we are trying to figure out that, then we'll say that we are trying to figure out the limit. Limit of f of x when x approaches A. Rudvi is saying, sir, where to get full expansions of limits? Rudvi, in this session, I'll tell you all the expansions which are needed in limits. Is that okay? But have patience till the right time arrives. So everybody got this point, everybody understood it without any confusion. Shall I move ahead from here, all the participants? Now with this, I think the concept of limit is very well understood by you all. So here, let me take one more example. Here, let's say this is a curve and this is a point A. So if x is approaching A from left hand side, the curve is approaching this point. If x is approaching A from right hand side, the curve is approaching this point. Yes or no? So what does it mean? It means that its left hand limit, its right hand limit, both are approaching a certain fixed value. And if both of these sides, from left neighborhood of A, if I approach A, from right neighborhood of A, if I approach A, I see that the limits, the left hand limit, the right hand limit, they both are approaching the same value. Then we say that the limit of this function is defined. Limit of this function exists at A. There are two things, students, you need to understand it. Pay attention, everyone. I'll get or take one more scenario, one more example so that you can process it comfortably. All I'm saying is that let's say here, this is how this function is going here. This is how the function is going here. Well, let's say this is how the function is going here. And this is the value of this function at this point A. Everybody understanding it? What did I just say? I said that here, if you notice, at A, this is the value of the function, which is f of A. But if A is approached from right hand side, the function approaches this value, this value. If A is approached from left hand side, the function approaches a value, which is this value. It is giving me a pattern. It is showing me a trend that it is going towards this value. Although at this point, the value of the function is something totally different. But let's say this is a value which I'm denoting by L for a while. Then I'll say limit x approaches A on f of x is equal to L. Sir, why? Because the left hand limit and the right hand limit, the function from left hand side of A, the function from right hand side of A approaching a fixed value, a same value L. The LHL and RHL are same. Everybody comfortably getting it? Yes or no? For example, if I take the example of signum function, do you remember that in our batches, one of the paid batches, a student calls signum batches as Singham function. So signum batches, signum function as Singham function. So signum, if I talk about, I hope you remember, signum is defined as what? So there is a curve, signum. So signum is defined as, or let's say if I directly write it as signum of x. So it holds three definitions, 1, 0 or -1. It is 1 as long as x is positive. It is 0 the moment x is 0. And it is -1 the moment x is negative. Remember that, students? So if I apply that logic here, if I try to draw its graph, sir, as long as x is positive, it is 1. As long as x is negative, it is -1. But the moment x is 0, it is 0. Now look at this scenario now. Look at this scenario now. What I'm saying is that, sir, function, which function? Signum of x. Signum of x. When x approaches 0. So, sir, when x approaches 0, I think there are two cases. Which case, sir? If 0 is approached from right hand side. So, if I approach 0 from right hand side, what value do I move toward? Sir, we are going towards 1. And if 0 is approached from left hand side, what value are we approaching towards? Sir, we are approaching towards -1. We are approaching or moving towards -1. So what I'm trying to conclude is that 0, when x approaches 0, signum of x shows two behaviors, two patterns. Sir, it approaches 1 from right hand side, it approaches -1 from left hand side. So sir, in that case, you need to consider both left hand limit and right hand limit, which means here I'll say 0 plus, this would mean the right hand limit, which means 0 is approached from right hand side. So 0 is approached from right hand side, it is written as 0 plus, which means when 0 is approached from right hand side, signum of x gives you a value 1. But when I talk about left hand limit means what? Sir, x is approaching 0 from left hand side. So if x is approaching 0 from left hand side, it is approaching -1. Signum of x approaches -1. everybody comfortably able to get this statement, concept of LHL, RHL. And it has nothing to do with the value of the function. The value of the function was 0. If I ask you the value of the function at 0, signum of 0 is 0. Absolutely, Dhiru. I hope everybody is getting it. Good, Mishra ji. That's brilliant. So are you all realizing whatever we are discussing here? Any queries or confusions? Let me take one more scenario, because now you might be thinking that limit is a concept which is always a finite value. Let us draw the graph of reciprocal function. Remember the graph of reciprocal function we have studied when we were talking about f of x is equals to 1 by x. So when you draw the graph of f of x, which is 1 by x, this is how you draw. So this is the graph of f of x, which is equal to 1 by x. Remember that, students? Now again, pay attention everyone. If I ask you that this is a value 0, which I approach, which means if I say limit x approaches 0 on this f of x, then again, sir, you would say that there are two scenarios. You should consider both of these scenarios, because if 0 is approached from right hand side, which means 0 is approached from right hand side, I'm approaching a value plus infinity, ain't I? We are indeed. I hope everybody is clearly noticing it. So what I'll say here is that, sir, limit x approaches 0 from right hand side. 0 from right hand side in the world of limits is written as x approaches 0 from right hand side, 0 plus on what? F of x, which is the curve 1 by x. So this value is plus infinity. So I'll write it as plus infinity. Everybody got it without any confusion? Good. Priya Ranjan Sahu. Now similarly, if I ask you limit x approaches 0 from left hand side, what is your opinion in that case? Sir, if x is approaching 0 from left hand side, so x is approaching 0 from left hand side, which means we are approaching 0 from left hand side, fx is going in what direction? Sir, fx is moving towards minus infinity, isn't it? It is. So what I'll say here is that, sir, if x approaches 0 from left hand side, we read it as x approaching 0 minus, then 1 by x approaches minus infinity. Everybody understood the concept of RHL and LHL? Are you feeling confused? Tell me honestly. Are you all getting the concept of limits? Are you all able to process it? I hope it makes complete sense now. So if I wish to define fx, limit x approaches 0, what I'll say is, sir, it is not defined because LHL and RHL are not equal. I hope you're getting it. Let's take one more case so that you can totally process the idea of limits and you get it completely. Absolutely. Let me draw the graph of, let's say, GI for fraction, whatever you wish to take. Let's say fraction part of x. So fraction part of x is drawn like this. I hope you do remember it. Fraction part of x has a graph drawn like this, yes or no? These are all the points which is 0, minus 1, 1, 2, yes or no? So let's say, sir, we are wanting to, okay Arnav, I get it. We are wanting to figure out its limit when x approaches 2. So what is x approaches 2 limit? So I think, sir, LHL, RHL both needs to be worked out indeed. So when x is approaching 2 from left hand side, the curve is approaching this value, which is what? 1. Noticing it on the y-axis. But sir, if x is approaching 2 from right hand side, the curve is approaching what value? 0. So did you all again get this statement that in order to see the concept of limit to be defined, you need to consider left hand limit and right hand limit, which means here in this case, I'll say limit x approaches 2 from left hand side on fraction part of x. 2 left hand side, fraction part of x gives you 1. Everybody got my point? Similarly, if I say limit x approaches 2 from right hand side on fraction part of x. So 2 is approached from right hand side, fraction part of x goes towards 0. Everybody now comfortable with the concept of limits, or are you still feeling confused? I'm constantly trying to make you understand one very basic idea, that we look at a number and we look at its graph, and around that point we notice or observe or try to get this idea that in which direction is this graph going. What pattern is it giving us? What prediction can we come out or come up with? I hope everybody got this idea in a very crystal clear manner. For example, here, this is a function which has the definition x square minus 1 upon x square minus 3x plus 2 whenever x is not 1. Okay, so there is a function which has two definitions. Piecewise definition it has. The definition when x is not 1 is x square minus 1 upon x square minus 3x plus 2. And when x is 1, it is taking a definition 2. So this is the definition when x is not 1. This is the definition when x is 1. Let us try and see what's the problem over here. The problem is very simple. That, sir, at 1, this is not the expression. At 1, this is the f of x. Okay, we get it. Let's try to draw it. So when I try to draw it, what I'll say here is x square minus 1 is there in the numerator, which I can write as x minus 1 into x plus 1. What about the denominator? X square minus 3x plus 2. So minus 3x can be splitted as minus 2x minus x. So this I can write as x square minus 2x minus x plus 2 because the sum will be minus 3. Product will be plus 2. So two factors are going to be x minus 2. I'll take x common from here, minus 1 common from here. So other factor will be x minus 1. So can I directly write it as x minus 2 and x minus 1? Yes or no? Everybody got it. Now I hope you do realize and understand that here x minus 1 can be cancelled because x is not 1, which means this is non-zero. So a non-zero upon non-zero will be a same value which can be cancelled. So here I can simply get rid of it and I can take the definition in a better format like this. First of all, did you all understand how am I simplifying this function? Did you all get this or are you still feeling confused? Shall I move ahead from here? If you are getting it a little clearly, then here, please pay attention everyone. X minus 1 are cancelled. So f of x gets a totally new different definition, which is defined as x plus 1 upon x minus 2 whenever x is not 1. And if x is 1, it is taking a value 2. First of all, everyone with me? So now what? Now let's say I want to check it in the neighborhood of 1. I mean, when x approaches 1, what happens to f of x? So I hope you get it that f of 1 is 2. I think this clearly helps you in interpreting that f of 1 is undoubtedly 2. So at 1, the value of this curve will be 2. Good evening, Vijay. Good evening, everyone. Good to have you all here. But the problem here is that, sir, how do you see it as? Okay. So when x is approaching 1 from either left hand side or right hand side, I'll be talking about this. Yes or no? So if I partial differentiation, why? You don't need it, Vishal, here. So if x approaches 1, I'm not saying x is 1. When x is 1, it is 2. But when x approaches 1, I'll be using this definition because either on the left of 1 or on the right of 1, this is the value it will be showing or demonstrating. So either you put a value slightly greater than 1 or slightly less than 1, it will start giving you a pattern that in which direction it is moving. So if I put 1, I'll get the idea that where will it be exactly at 1 if I follow this pattern, which is the right hand limit and the left hand limit. So 1 plus 1, that's 2. 1 minus 2, that's minus 1. So limit I get is minus 2. And I hope you do realize that there is a problem. Sir, what problem? That from left hand side and right hand side, this curve fx will go towards minus 2 around 1. But sir, at 1, it will take a value 2. If you are not processing it, let me show it to you through a graph. Look at this. When you try and draw its curve, so here I'm trying to notice a simple curve, let's say around 2. A generic, a random curve I'm taking around 2. So I am saying that just on the right of 2, just on the left of 2, if I notice it, just on the right of 2 and just on the left of 2, if I notice it, the curve tells me that in which direction is it going. Saras, I think it is Saras or Samir, whatever it is, whoever it is. is asking us a one very interesting question. Sir, are one shots? Shorts, they are not shorts, they are short. So are one shots enough for JEE Advanced? I'll say one shots are not even enough for JEE Mains if you are not practicing. Have I answered your query or should I elaborate it? We totally and humbly agree with this statement that one shots are good for revision. If you have studied a chapter, if it is created as a backlog in your preparation, or if you want to revise it, if you want to go through it very quickly, then one shot should be referred. But let's say if you're watching it for the first time, then I'll say, instead of watching it for the first time here through one shot, no, that's never advised. You go and watch the full lecture, the complete lecture. But then, sir, how should we utilize one shots? Then why are you, delivering this lecture in that case? I'm delivering this one shot, first of all, for those students who want to revise it or want to cover it if it was created as a backlog, which means they have already studied this chapter, but they could not study it properly. So they'll get to cover it in this one shot through this one shot. And then second thing here, sir, will that be enough in that case? No, never. I'll say after watching the one shot, you get your short notes, which you can download from our website as well if you are enrolling for this free course. And then after revising all those short notes, those questions and everything, you start solving previous year's questions of JEE Mains, at least last 6 years. It will give you a complete clarity. So instead of, learning or reading a lot of theory or watching a lot of one shots, I'll say practice questions. They'll teach you a lot. Virat Shukla, somebody has told me that my daughter is 3 years old and she is already late to prepare for JEE. So how should I answer this question? When should we start preparing for JEE? You should start preparing for JEE. I mean, it depends that what kind of base do you have. But even, let's say, if it is less than 180 days left for January attempt of JEE, you are in July, late July right now, January attempt of JEE, let's say less than 6 months, less than 180 days, still you can prepare. Trust me, if you are sincere enough. And a strategy video will be released on that soon. The video will answer your question, Virat. So stay tuned. A video will be released soon there. How to get your short notes. The notes will be uploaded on our pw.live batch. The free batch, the link to the free batch is given in the pinned comment and in the description. Excellent, Virat. In that case, we are obliged that people like you are here attending, watching and learning. Good to have you. So with this, first of all, did you all understand the concept of limit? Let me explain it with more examples. Look at this case. There I'm asking x minus 2 upon x minus 3 when x is approaching 3 from left hand side, 3 minus. So I'll say limit x approaches 3 minus on this x minus 2 and x minus 3. So one of the practices which you follow in board examination is that this x, this is 3 minus, which means you just assume that 3 is approaching, x is approaching 3 from its left neighborhood. So on the x-axis, you have this value 3. In this case, they are asking you that if 3 is approached from its left side, what value will this expression approach? What value will this expression approach? So one of the best practices is that you try and check it at 3, what happens? So add 3, 3 minus 2, 1, 3 minus 3, 0. So sir, it will be 1 upon 0, which is not defined. But the problem is, sir, will it be plus infinity or minus infinity? So that all again depends. Vijay, be careful. Will it be plus infinity or minus infinity? I have been telling you this constantly. I think that's exactly why we have kept this question deliberately, to check whether we have understood whatever he has explained so far or not. So yes. No, it's not an indeterminate form. It is simply not defined at 3. But if I wish to check it around 3, from the left hand side of 3, I'll say 3 minus 2. So numerator approaches 1. I hope you're getting it. Imagine a value just less than 3. For example, 2.7, 2.8, 2.9, 2.999 or something like that. So if I'm approaching 3 from the left hand side of 3, these are the values. So if I put these values, it's like 0.3, 0.2, 0.1, like that. But all those values are negative from the left hand side of the 3. if I put these values 2.7, 2.8, 2.9, 2.98, 2.999 and so on, it will be approaching 0. It will be approaching 0 from the left hand side of 0. Are you processing this idea or are you feeling confused? So it will be approaching 0 from the left hand side of 0. So it will be something very small, something very close to 0, but with a negative sign. Minus 0.3, minus 0.2, minus 0.1, minus 0.02, minus 0.01, and so on. But it is very small, close to 0, but negative. So we know 1 by 0 approaches infinity. But negative of infinity is minus infinity. So answer over here is minus infinity. That you can say with intuition, with your observation. Let's say you don't get it. Let me explain it with the RHL. Let's say the question was limit x approaches 3 from right hand side on this expression x minus 2 upon x minus 3. In that case, what would be the answer, sir? Now imagine this. 3 minus 2 in the numerator is 1. I mean 3.2, 3.1, 3.001, like that. If I try x as, it will be approaching 1. But a value just greater than 3 if I put, it will be approaching 0, but from the positive side. I mean, imagine this. X I am trying as 3.2, 3.1, 3.01, 3.00001, and so on. So these values if I try, and from them if I subtract 3, I'll keep getting positive zeros. I mean, I'll keep approaching towards 0 from positive side. So it will be positive 0, getting it everyone, and 1 by 0 approaches infinity. So that's my point here. You just cannot say that x minus 2 upon x minus 3 when x approaches 3 will be infinity. No, it depends. When you approach it from left hand side, it is minus infinity. When you approach it from right hand side, it is plus infinity. All the students who are watching it sincerely, getting it sincerely, understanding it sincerely, have understood this part or not. I am simply asking you the concept of left hand limit and right hand limit. Do you process it? Everybody got it? Yes or no? All the participants. Excellent. That's brilliant. So if you have gotten it, let's solve one more question so that you get more clarity. Look at this GIF. GIF of x. So GIF of x, I hope you remember, from 0 to 1, then 1 to 2, then 2 to 3. So between 2 to 3, from 1 to 2, I hope you do understand, from 1 to 2, this is how the graph looks like. But from 2 to 3, this is how the graph looks like. Yes or no? Excellent, excellent, good, good. We have Masha as well. My daughter loves watching this cartoon, which is very threatening cartoon, I'll say, for parents. I mean, no child should become like her. So here, let's say if 2 is approached from left hand side and right hand side, then what happens? Sir, if you want to approach 2 from left hand side, so when you approach 2 from the left hand side, the function approaches 1. But when you're approaching 2 from the right hand side, the function approaches 2. So I think it is very well defined that here, when you are putting limit x approaches 2 from left hand side on GIF of x, it will be approaching 1. But when you are approaching 2 from right hand side, GIF of x will approach 2. And of course, if the limits are not same, its limit does not exist. I think we have already proven it. So did you all get a decent clarity and idea on this concept of limit? Are you able to process? Are you able to get it now? Are you able to process this idea of limits in your brain? All the participants. Great, great, great. Excellent. Good, good, Vijay. Good, Shubhash. Excellent, Mishra ji. That's good, everyone. Great. Now with this, let us talk about this another case. We are told that fx is either x or x minus 1. It is x as long as x is rational. It is x minus 1 as long as x is error rational. Now look at this scenario. This is again a very beautiful case. Let's say this is how I'm drawing it. And around 1 by 2, I want to check its nature. Faizan, again, it depends. How sincerely are you doing it? How seriously are you doing it? If you are doing this book for your preparation, if you are doing all the examples, all the theory, all the good practice questions which cover a lot of variety, the all parts, if you are covering sincerely, then it is always good. Yes. But along with this, I'll say this will create a good foundation, a good base. But later on, later on you need to solve JEE Mains and Advanced PYQs, previous year's questions, and some more good books which are specifically prescribed for JEE Advanced, which you already know. Coming back to the discussion, I am willing to figure out its nature around 1 by 2. So, sir, I hope you know that between any two numbers, for example, 0.001 I write, and I write 0.002. Even these two very small numbers I have taken. Even between these two numbers, I will find infinite rational and irrational numbers. I hope you do accept this fact. So with this, my point is pretty simple. Around 1 by 2, if I approach 1 by 2 from left hand side or right hand side. First of all, exactly at 1 by 2, what happens? Sir, exactly at 1 by 2, yes, we know 1 by 2 is rational. So if I put 1 by 2, at 1 by 2, the value will be 1 by 2. Definitely at 1 by 2, the value will be 1 by 2. But in the left of 1 by 2, in the right of 1 by 2, there will be infinitely many rational and irrational numbers there. On the right of 1 by 2, there will be infinitely, I'm writing infinitely like this, I hope you're able to process it. There will be infinitely many rational and irrational numbers there. Set of rational is Q, set of irrationals is QC, complement of Q, and it combinedly is called set of real numbers. So what I'm saying is that around 1 by 2, on the left of 1 by 2 and on the right of 1 by 2, if there is any rational number I take, let's say this number over here is the rational number. So for rational, it will be 1 by 2. I mean, approaching towards 1 by 2. But if it is irrational, it will be 1 by 2 minus 1, which is what? Minus 1 by 2. Yes or no? So it will be approaching this value. So if you notice, I'll see a graph like this. There will be infinite rational and irrational numbers. So for those rational numbers, I'll see the pattern to be approaching towards 1 by 2. But for those irrational numbers, I'll be seeing the pattern to be approaching minus 1 by 2. So are you not noticing that, sir? It will be fluctuating. It will be fluctuating between minus 1 by 2 and 1 by 2. I mean, let's say there is a number 0 point. There is a number around 1 by 2 is what? 0.5. So 0.51, let's say this is the number. And I just moved slightly left to it. So I'll find any irrational number. I'll just move slightly right to it. I'll find another rational number. So let's say this was rational. I'll find irrational, then irrational. And between them, there will be again infinitely rational and irrational. So it will keep fluctuating. It will keep oscillating between irrational and irrational. So the moment it gets rational, it becomes 1 by 2. The moment it takes irrational, it will become minus 1 by 2. So is it even defined? No, sir. When you look at from the left or right hand side, you get confused. Why? Because you see it to be moving towards 1 by 2. But no, when you notice it, it is moving towards minus 1 by 2 as well. So you will see its graph around minus 1 by 2, to be, fluctuating, to be oscillating. So you just cannot predict it. You just cannot get the limit. You just cannot define the limit, because left hand side and right hand side both are moving towards either 1 by 2 or minus 1 by 2. So I just don't get it, sir, in which direction it is going, because we cannot get the fixed prediction. And if we cannot get it, again, I'll say the limit is not defined. The limit does not exist. Through these examples, I've just tried explaining all of these things, and I'm sure it makes complete sense now. Or are you still feeling confused? Give me a quick update, a quick response. Here in this question, we are told that this is 2. Let me rewrite this expression. This is 2 to the power minus 2, and this is raised as a power of minus 2. So 1 upon 1 minus x is a power of minus 2, right? And their limit x is approaching 1 from right hand side. Now imagine this. You can do it in your brain if you're preparing for IDJ. Absolutely. LHL and RHL are not same, and hence I'll say it does not exist. Absolutely. Now, look at this. When x approaches 1 from right hand side, imagine this. You are approaching 1 from right hand side. So it's like you are approaching 1.2, 1.1, 1.01, 1.001, and so on. So you're approaching 1 from right hand side. So imagine this 1 minus 1.2, which is minus 0.2, 1 minus 1.1, minus 0.1, 1 minus 0.1 minus 1.01, and so smaller value. But still, if I'm getting numerically very small value close to 0, but this expression will still be negative because this x is slightly greater than 1. I'm looking in the neighborhood of x. So this x over here is slightly greater than 1. So if this is slightly greater than 1, 1 minus any value which is slightly greater than 1 will be close to 0. But what will it be? Negative or positive? It will be positive. No, negative. So 1 minus x as an expression will approach 0 but from left hand side. So can I write it as minus 0? I hope it does not make any sense because 0 is neither positive nor negative, but it is approaching 0 from negative side. Yes, Mishra ji, these are basic, simple, direct questions which you can find in a lot of standard reference books. You'll find it almost everywhere, these kind of questions. Not only in the book which you are advising, but it will be found in a lot of other books. Here comes my part, where I'm saying that 1 minus x will be very close to 0 numerically, but it will be negative. So 1 upon 0 is infinity, but because of this minus sign, this whole thing will be approaching minus infinity. Everybody got my point? Now, try and understand this. The whole problem I am seeing that this minus 2 to the power minus infinity. So minus 2 is the side. 2 is raised to the power minus infinity. Now you help me with this. If I draw the graph of 2 to the power x. This is the graph of 2 to the power x, a to the power x when the base is greater than 1. So if x, which means the power is approaching minus infinity, the curve is clearly approaching 0. So I hope you do realize and accept that this thing, 2 to the power minus infinity, approaches 0. Yes or no? Everybody processing it, everybody getting it. Yes or no? So again, whether it is 0 from left hand side or right hand side, minus 0 plus 0, it doesn't matter. It is very small. And 2 raised to the power, which is very small, is 1. So this limit is finally 1. Everybody got it. Everybody understood it. Everybody got a crystal clear idea. Or shall I explain it the way you do it in boards? Sir, why are we doing it like this? Is it not very confusing? Will this not really help us in boards? This will not help you very much in boards, but this is exactly the kind of thought process which is required and expected out of you if you're preparing for ITJ. This is exactly how you should be able to think, especially when you're looking at calculus, when you're looking at these concepts of limits, continuity, and differentiability. If you ask me to do it systematically, I could have done it, but I hope this is also making complete sense the way we have done it. Yes or no? Shall we move towards few more questions so that you get it more clearly? Everybody, look at this example again. Pay attention, everyone. Here it says, x is approaching 0 from left-hand side. Okay. X square minus 3x plus 2, x cube minus 2x square. Okay. Then here, sir, 0 is approached from left-hand side. Left-hand side means what? You are getting towards 0, but you're coming from the left-hand side. I hope you're understanding minus 0.1, minus 0.2, minus 0.3, minus 0.4. So you're moving towards 0 from left-hand side. So you should be getting this idea that we are approaching 0 from which side. Okay. Now, sir, when we approach 0, let's say right or left, we don't care right now. But if we approach 0, what happens? This approaches 0, this approaches 0, this stays 2, this approaches 0, this approaches 0. So I got something 2 by 0. But trust me, there is a problem. This 2 by 0 will be positive or negative, that you need to decide. This 2 by 0 will be positive or negative, that you need to decide. Getting my point, everyone? If you are not getting it, let me help you with a very simple conclusion. Let me help you with a better idea. Let's do it in a more proper manner. Let's say here we have this thing. Let me factorize it first. So this is limit x approaching 0 from left hand side. X square minus 3x plus 2 can be written as x square minus 2x minus x plus 2. And this thing, if I take x square common, I'll be left with x minus 2. So in the numerator, it will be x minus 2, one of the factors. Here also it will be x minus 2 if I take minus 1 common. So other factor will be x minus 1. Whole thing gets divided by x squared times x minus 2, where limit x is approaching 0 from left hand side. Everybody got it? Everybody understood it? Excellent, excellent. Good, Mishra ji. I was actually interested in knowing whether you guys tell me whether it is plus infinity or minus infinity. That's exactly what I was interested in. Now, I hope so far there is no confusion on whatever I've done. X minus 2, it will be something, whether positive or negative, but it can be cancelled. I hope there is no query or concern so far. Now, this expression gets simplified as limit x approaches 0 from left hand side, where I'm having x minus 1 in the numerator and x square in the denominator. Now, x square, whatever value of x we put, it will be positive. So, sir, it will be positive. It will be positive. But when 0 is approached, whether from left or right, x square will be even smaller. Yes or no? Yes or no? So, this denominator is approaching 0 from positive side. So, it is positive 0. I hope you're understanding positive 0. We are not saying it is exactly 0, but it is approaching 0 from positive side. Numerator, anything less than 0 is negative, minus 1 is negative. So it is something finite. It is something finite. Of course, finite means around minus 1 and that too negative. So 1 upon 0 is infinity, but minus 1 upon 0 approaches minus infinity. So did you get it? The answer to this question will not be plus infinity, it will be minus infinity. Some of you may say that, sir, when x approaches 0, this is 2, this is 0, 2 upon 0 is infinity, which is wrong. The correct or the more appropriate answer here will be, minus infinity. That's exactly the kind of observation I'm hoping and expecting. Exactly, Mr. Sandy. I hope everybody is realizing whatever I'm trying to suggest you here, that you should be able to think in this meticulous, in this nuanced, in this so minute level manner. Are you all able to get it? Let's do one more question so that you get it more comfortably. Evaluate the left and the right hand limit for this function. So, sir, we are told at 4 it is 0. Okay, at 4 it is 0. But what is happening around 4? So, let's say x is approaching 4 from left hand side on this f of x. X is approaching 4 from right hand side around f of x. Sir, what is f of x? F of x is mod x minus 4 upon x minus 4. F of x is mod x minus 4 upon, I'm really sorry, I made a mistake. This should be x minus 4 simply. And this is again x minus 4. Correct me if I'm wrong. Now, you give me two scenarios. Here in this case, x is approaching 4 from left hand side. Yes or no? So x is approaching 4 from left hand side. It means what? Sir, 3.9, 3.8 like that. So this whole expression will be negative. So if anything inside the modulus is negative, it opens with the negative sign. So x minus 4 will open with a negative sign, which is 4 minus x. And what is this? This is x minus 4. So 4 minus x upon x minus 4, when x approaches 4 from left hand side, is clearly going to be minus 1. So left hand limit gives you minus 1. Yes or no? If I approach 4 from right hand side, like 4.1, 4.2 like that, minus 4 will be 0.1, 0.2. That's positive. Inside mod, if I'm taking or dealing with a positive value, it opens as it is. So it will be x minus 4 in the numerator, x minus 4 in the denominator, and the limit is approaching 4 from right hand side. This upon this is 1. So this RHL will be 1. So I think we have worked it out. The left hand limit is minus 1. RHL is plus 1. They are not same, which means limit does not exist. With the time, you will, Sandy, don't worry. Have patience. A teacher knows how to teach, so let the teacher teach. You will definitely see better problems with the time. Have patience. With this part, shall I move ahead? Everybody focusing here. Algebra of limits. I'm first of all making you comfortable with this concept through this one shot, where we are believing that you are wanting to understand it genuinely and sincerely, and gradually, Absolutely, Sandy. They were not continuous. Can you tell me the reason why were they not continuous? Good observation. So with this, here I am. Another case presenting to you. Let's say when x approaches a, there is a function which approaches L, which means from left or right, whatever side I approach a, it will be giving me a fixed limit L. Similarly, if x approaches a, this function gx gives you a fixed finite value, either from left or right, which is small m. So these two limits are fixed. I'm not saying these are the values of these functions. I mean, at a, f of x could be something else. At a, g of x could be something else. I'm not interested in that. Right now, I'm interested in what value fx approaches, fx goes towards if x approaches a, it is L, and gx approaches m if x approaches a from left or right hand side. Everybody comfortably got it? So algebra of limits says that, sir, if fx plus gx is needed to be done, or fx minus gx is needed to be done, on same limit x approaches a, then I can add or subtract the individual limits depending on the sign between them. Same holds true for their product as well, which means fx into gx, limit x approaches a is needed to be done. So I'll multiply their individual limits. Getting it, everyone? Yes or no? If fx upon gx is given, where fx approaches L, gx approaches m, so I can divide L by m, and of course it should be provided that m is not 0. Same holds true for a scalar. So if a scalar gets multiplied to a function, so function approaches L when x approaches a, so it will be k into L. I hope that's something really basic, easy, direct, straightforward. Comfortable you all are, I believe so, with this concept. Absolutely, it's only they are finite. So L, M, N are finite because had they been infinite, I would have put infinite sign. Absolutely, but a very minute observation you are making, Sandy. Because if they become infinite, there could be a case of any indeterminate form, which we haven't explored yet, but I'll be bringing them very soon. Good. Great, Mishraji. With this, if I'm told fx to the power gx, where both L and N are finite, then it will be L to the power m, direct. Everybody got it? Everybody got it? Let me put this condition or this very observation that if L and m exist, so exist means what? They are finite. What if they are infinite, sir? Then it will be infinity plus minus infinity. It will be infinity into infinity. It will be infinity upon infinity, right? So those are different cases. For example, if this is something, in this case, if this is something infinity to the power infinity, like that case. So these are the very basic things which you should be aware of. For example, here, f of g of x when x approaches a. So I'll say f of limit x approaches a on g of x. X approaches a, g of x is m. So my answer will be f of m. I hope you got it. Yes or no? But around m, f should be continuous. Sir, what is the meaning of this line? I will explain it when I explain the concept of continuity to you. But right now, forget it. The same applies to log or ln, e or exponential functions, modulus, or even any plus minus infinity as well. Please remember it. If x approaches a, and then in that case, fx approaches either positive infinity or minus infinity, its reciprocal when x approaches a will be approaching 0. Please remember this direct and straightforward fact. Will you all, everybody? Any confusions or queries so far on whatever we have studied or discussed regarding limits? Everyone comfortably processing it? All the participants? Yes or no? Everybody getting it? Yes or no? Now, if I could explain some cases to you, here we are with another case. Can you help me with this case? X approaches infinity, sin x upon x. Sir, what do you think in this case? So I hope you do accept that, sir, if you notice the graph of sin x, so it keeps on going like this. So at infinity, it will be taking some value between -1 and 1. I don't know what exact value, but it will be attaining some finite value between -1 and 1. So if x approaches infinity, sin x approaches some value between -1 and 1. I don't know, but something finite it will attain between -1 and 1. And when x approaches infinity, x approaches infinity. Now imagine this. This is an expression in your brain written as something finite between minus and 1 upon infinity. And that is plus infinity, because infinity, we are going towards extreme. No, 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 no. Does not exist. No, 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 no. Something finite upon infinity approaches 0. Imagine this. This is finite, which means something small. With respect to infinity, it is something really small. Why do you have to use L'Hopital here? It's direct, straightforward. No, it's not undefined. It's 0. It's 0. In the numerator, it is something finite. And in the denominator, it is infinity. Finite upon infinity is straightforward 0. It's not infinity upon infinity, any indeterminate form or anything like that. It's very direct, simple, straightforward. Everybody got it? Or shall I re-explain this? Now, let me explain few more cases which you should take care of. Good, Vijay. I hope you are understanding it now. Mishra ji is giving it with the squeeze theorem. Absolute Mishra. Good, good, good. Excellent. Yes, it is not indeterminate, Sandy. Indeed, it is not. Let's say if product of two functions when x approaches c limit exist, then what does it mean? What can I conclude? It may mean that both of them exist. It may mean that one of them exists and other does not. Sir, how is that really possible? I'll show it to you with one of the examples. Exactly, Mishra ji, your statement is absolutely correct. Sandy, don't worry. Sandwich theorem or a squeeze theorem, I'll explain in the upcoming slides. Don't worry about that. And Mishra ji, yes, you're coming up with a very valid observation that between -1 and 1, it will keep on oscillating. So it will be something finite upon infinity will be 0. I am saying that let's take a scenario where f of x is x square minus 4. G of x is this x square plus x minus 6 in the denominator. So f of x into g of x is this. When x approaches 2, it is 4 by 5. When x approaches 2, it is 4 by 5. Getting my point, everyone? Yes or no? Yes or no? Yes or no? But if you ask me that, sir, what happens when x approaches 2 on this, then I'll say it does not exist. I hope I'm trying to demonstrate one very simple direct observation, which is this, that when x approaches 2, g of x does not exist. When x approaches 2, f of x exists, which is 0. So a function's limit exists into a function's limit does not exist. Sir, what would the product be? Will the product be does not exist? No. It can exist, it cannot exist. You have to work it out. So in this case, it does exist. So when product of two functions, and if you apply a limit on it, exist, then one of the cases could be both functions limit at that point exist, or other case could be both of them individually doesn't exist, but their product may exist, which has happened in this case. Everybody got it? As I've explained in this case, that both of them may not exist, but their product could exist. Look at this very beautiful scenario. Look at this very beautiful scenario. F of x, when x approaches 0, limit does not exist because left hand limit is 1, right hand limit is 2. So left hand limit and right hand limit are not same. So x approaches 0 on f of x does not exist. Do you all agree? X approaches 0 on g of x. So when x approaches 0 from left hand side, it is 2. When x approaches 0 from right hand side, it is 1. And 2 and 1 are not same. So when x approaches 0, gx does not exist. So at 0, limit for fx and gx both does not exist. So what will be the product? Okay, the product. Fx into gx I want to talk about, yes. So for negative values of x, it will be 2 into 1, which is 2. Sir, for positive values of x, it will be 1 into 2, which is 2. So, sir, fx into gx is 2 for all the values of x which are here. Fx into gx is 2 for all the values of x which are real, which means what? Sir, that means fx into gx when x approaches 0 is 2 because it is a constant function. So, are you realizing this thing? Are you realizing this very beautiful thing? Sir, what thing? That fx gx and fx into gx. So sir, if x approaches 0, fx exists. If f of x approaches, let's say, if limit x approaches a, fx exists, gx exists. So something finite into something finite will be something finite. So product will exist. But sir, when x approaches a, fx exists, gx does not. Then what can happen? Sir, it may exist or it may not. I just don't know. We'll have to work it out. Same, if fx doesn't but gx does, in that case also, sir, it may exist or it may not. We have to manually work it out. We have to solve it. Other case, neither fx nor gx exist, the limit. But still, again, in that case, fx into gx may or may not. I just have to work it out. Yes, there will be piecewise questions. Don't worry about that. Piecewise definitions will use. And I think I have just demonstrated some examples, didn't I? Absolutely. So if you all are getting it, shall I move ahead from here, all the participants? Here comes one more case which I wish to explain. Pay attention, everyone. Let's say we have something like this. fx plus gx exist. Then what can we conclude? In that case, sir, both should either exist or both should not exist. What did I just say? If limit x approaches c, fx plus gx or fx plus gx is defined, in that case, either both of them will exist or both of them will not exist. Sir, what does it mean? It means, let's say, limit x approaches c, fx exists. Limit x approaches c, gx does not exist. In that case, fx plus gx will not exist. Am I making myself understood? Are you making some sense out of whatever I'm explaining? Are you getting it comfortably? Or what I'm saying? Let's take a very simple, very decent, very direct example of this GIF. Sir, GIF of x at 1 does not exist. The limit, we have already understood it. Fraction part of x at 1 does not exist. So individually their limits don't exist. But if I do their sum, this is the example, Sandy. Are you not looking at it? GIF of x plus fraction part of x, we have already studied it in relations and functions, is given by x. And when x approaches 1, x will approach 1. So are you not believing this? That limit for this function did not exist. Limit for this function did not exist at 1. But the sum of these two functions, their limits did not exist at 1. The sum, when I did, in that case, limit existed. Wait a second. I did not say that if for two functions, their limits don't exist, then for their sum, the limit will exist. No, I did not say this. You may have assumed it. I absolutely did not say this. Then, sir, what did you say? I said opposite of it. I said converse of it. If x approaches c, fx plus gx exist, then either both of them individually will exist, the limits, or both of them will not exist. But you will never see a case where this limit exists, this doesn't, or this exists and this doesn't. And despite that, their sum exists. Bharat is asking, can a function be continuous at a point but not differentiable here? Yes, Bharat, it's a very simple scenario, which we'll talk about when we discuss differentiability. Right now, I'm explaining limits, but still, if you want to, I can give you a scenario like this. Look at this curve, a sharp turn here. So it is continuous here, but not differentiable. Why? I'll explain this when I teach you differentiability very soon. But right now, just trying to give you an example. If I could culminate all what I've said so far, then I'm saying a very simple, a direct fact that let's say there is a function fx, there is a function gx, and I want to talk about fx plus gx. Getting it, everyone? The sum. So, limit x approaches, let's say a. fx exists, gx exists, and they are finite. So their sum will be finite. Of course, sir, it will happen. Let's say, sir, at x approaches a, fx exists, gx doesn't exist. Then you can very undoubtedly, without any hesitation, can say that fx plus gx will not exist. If fx doesn't exist but gx exists, then fx plus gx will not exist. You can say this again without any hesitation. But sir, fx doesn't exist, gx doesn't exist. In that case, sir, it can or it cannot. I will have to figure it out manually. Everybody got my point? Everybody understood my point, or shall I re-explain this? Now let us understand the concept of sandwich rule. Sandwich rule is a very beautiful rule which requires some awareness, which requires some prior knowledge of graphs and all. But if you have a better understanding of few things, you can crack it within seconds. Sandwich rule says that if you have, let's say, three functions, hx, gx, and fx, where fx is going like this, hx is going like this, and gx is going like this. Are you noticing something? I am saying that fx is the uppermost curve, hx is the lowermost curve, and gx is sandwiched between them. Gx is squeezed between them. Gx has no other reason just to follow the path between them. So there is a very narrow path over here, but gx is still passing through it. So sandwich theorem or squeeze theorem here says that if A is approached from left hand side, and if hx and fx are approaching a fixed value and a same value, then gx has no other choice but to pass through that point only. So if hx and fx are giving me a fixed finite same limit at a certain point, around a certain point, left hand limit and right hand limit, then gx will also attain that same finite fixed value. Can you first of all understand this with the help of this graph? Okay, Mishra. Good. That's brilliant. I hope no confusion regarding this so far. Any queries or concerns if you have, please ask. Shall I move ahead from here? Then I am simply saying, let's take this example. X square into sine 1 by x. X square into sine 1 by x. Look at this example. Or even before that, let me take an even simpler example like this one. This one I'll take. First of all, I'd like to show you that how do they behave. I'll give you a very straightforward direct example so that you understand it more clearly. Just give me a second, everyone. I'll try to show this to you. Two curves I'm trying to show you here. Let me first of all do this so that your eyes are not affected. And then we have a curve which is y is equal to under root x. And then we have another curve which is y is equal to ln of x. Right? These two curves I want you to draw and understand. Now please pay attention, everyone. These are the two curves. gfx plus gfx. Absolutely, Sandy. A very good observation. Now here comes the best part. Look at these two curves. This blue curve is under root x. And this orange curve is ln of x. And I hope everybody is noticing that blue curve is above the orange curve. Blue curve, no matter wherever I go, is above the orange curve because under root of x will be greater than ln of x. So as I've told you, to apply squeeze theorem or sandwich theorem, you need prior understanding of graphs. You need more better clarity of a lot of things. Sir, how and why? Can you please elaborate here in this case? Let's say this information I'm given, but not always this kind of data will be given to you in this question. You will have to work it out by your own intelligence, by your own brain, by your own awareness. So what are we told here? That ln of x, under root x and 0 have this relation for all x greater than 1. I'll say this is the relation for all x greater than 0. Then we are asked to figure out what will be ln of x upon x when x approaches infinity. There, sandwich theorem beautifully comes into picture. Please understand. What I know is that sir, ln of x at base e always lies between 0 and x. Always lies between 0 and x. So what if I divide all the three sides by x? Sir, x is approaching infinity, which means this is something very big positive number. So if I'm dividing all the three sides by x, which means I'm not dividing it by a variable so that I have to bother about the sign of this inequality. No, I know that this x is something very huge positive number. So if a number which is positive is dividing all the three sides, it stays sorted. The signs wouldn't change. So this will be 0 upon x, 0. This will be ln of x at base e upon x. And this will be x upon x, which is 1. Sorry. Did I make a mistake? Any mistake? No, I did not. I think we are going great. Any confusions or queries if you have, please ask. Are we comfortably getting it, all the participants? Have you gotten a decent clarity on this? I think we are going great. X is greater than 1. Then what did I do? I said this. Okay, I'm really sorry. I made a mistake. We were told that this is under root x. So it is not 1. It is under root x upon x, which is 1 upon root x. Now, yes. Thank you so much, Vijay. I made a mistake. You corrected it. Thank you so much. Thank you so much. Now, with this, I hope you do realize gx, fx, hx. Yes, Sandy. Thank you so much. So now if I apply the limit, where did it go? Now, if I apply the limit, so what does the concept of limit says? So limit x approaches infinity, limit x approaches infinity, limit x approaches infinity. So 0 is a constant function. Even at infinity, it will be 0. Even at infinity, it will be 0. Yes or no? Sir, 1 by root x, root of something very big will be something very big. So 1 upon something very big will be approaching 0. So this is also 0. Sir, this part, ln of x upon x when x approaches infinity. I think we have again defined it with the help of squeeze. All the three are continuous. The graph is bound to pass through this and this. It has nothing to, skip. It will pass between them, but it is 0 and 0. Both are 0. So it is also bound to be 0. So what do I conclude here? Can you help me with the answer, students? I hope you do agree that sir answer here will be that it has no other choice to be 0. So without even actually dealing with this limit, without even actually trying to finding this limit, I just worked it out with the help of squeeze theorem. Definitely, Santi. In this question, L'Hopital could have been better, but don't feel obsessed with that. JEE will ensure that you won't be able to apply L'Hopital at a lot of places. Even if you try to, you will end up wasting a lot of time. They know that people know it and people are obsessed with it. So they'll ensure it. Yes, in this case, but I wanted you to understand sandwich. That's why I've deliberately not brought it here. Let's take a 10 minutes break and then resume after 10 minutes. Is that okay? So I'm taking a 10 minutes break. I hope it's fine, everyone. So let's just meet after 10 minutes if it is okay, and then we'll resume again. 10 minutes.
हेलो। हाँ शायद देखता हूँ अरे ये रखा हुआ है कुछ नहीं करेगा। हाँ नहीं एक गिलास पड़ा है वो भी रखवाया जो एक हाँ उन्होंने रखवाया उन्होंने रखवाया। क्या खूब लगती हो रगत वाले लोग हैं, दो ग्लास एकदम प्योर वाला जैसे पीना वाली
नहीं सर मैं इधर ही हूँ मुझे मेरा वो ये माइक बाहर रखा हुआ है म्यूट कर दिया हेलो 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 चल रहा है Okay, students. So welcome back. Come back, everyone. Can you all hear me? Can you all see me? Shall we get started? Yes, timer is out, Sandy. Okay, so I hope this question was very well done. You all were able to understand it. And shall we move towards the next concept? Now I'm moving towards the indeterminate forms. Everyone. So far. Okay, so I hope you all can hear my voice. Come back, everyone, if you were watching it sincerely. If the laptop is still open, the video is still playing, if the mobile phone is still kept there, if you all can hear my voice, if you have hydrated yourself, if you have had something, eaten something, or if you have walked around, stretched yourself, come back, sit and start watching it again. Shall we resume? Bharat is asking, sir, can the sandwich rule be applied when the inequalities fail at just one point, but hold everywhere else near that point? It depends, Bharat, that in that case, where are you finding the limit? Are you finding the limit at that point where it is failing, or are you finding the limit where it is inside that? So it all depends that where are you finding that limit, right? Okay, Mishraji, good to have you all. Come back, everyone. So now we'll resume our discussion with what kind of limits? Indeterminate forms. So far what we have discussed, we have simply understood the concept of limits, which is different from the value of the function at a point. And the second thing is that how limit needs to be evaluated with very basic things, left hand limit, right hand limit, and this concept. Yes, Kutapi will be bringing class 11 chapter as well. Yesterday only, or rather in today's morning only, Shreshar and I were having a call and we were discussing, or rather planning, that how can we bring class 11th chapters. So we are going to start a series for class 11th as well. The same kind of series through one shots will be covering all the chapters. This free batch will bring for class 11 students as well. Don't worry about that. I hope you know that this free batch link is given in the pinned comment as well as in the description. If you click on it, you will receive this PDF after the session at no cost, and you'll get 24/7 doubt support mechanism or support system as well, where you can ask any doubt anytime. With this, here we are with the indeterminate forms. I am saying that, let's say if I check it at 1, which means if I apply limit x approaches 1 on f of x, what is f of x? X square minus 1 upon x square minus 3x plus 2, yes or no? So what will that be? So if you try to work it out, when you replace x by 1 in the numerator, 1 minus 1, 0. Okay, I'll start with trigo, don't worry. But here if I put 1, so 1 minus 3 minus 2 plus 2, that's again 0. So it is going to be a 0 by 0 form. So sir, what do you think? 0 by 0, what do you think? What do you think when it is a 0 by 0 form? I hope do you realize that here there is a problem that, sir, both of the values, which it's not on Telegram, we have our own WhatsApp channel, but we'll be keeping it on our free batch, which you can access by logging on our website pw.live. The link to our course is given in the description, which is free course. You don't have to pay anything for that. So here we have something upon something. But sir, this something is also approaching 0. This something is also approaching 0 when x approaches 1. But what 0? This 0 could be a little greater 0. This 0 could be a little smaller 0. Sir, what are you talking about? Greater 0, small 0. Yes, they do matter. They indeed do matter. So Shubham, the table guy, is saying for 1 power infinity can we use absolutely. It will work. Don't worry. It will necessarily work. Trust me. So here we are. Are you understanding it? So sir, there is a problem. What problem, sir? So the problem is that it is a 0 by 0 form. For you, I'll say that if numerator has 0, we say the fraction is 0. If denominator has 0, we say fraction is infinity. So how do you really decide it? Yes. So if you have 0 by 0 form, it is indeterminate. Indeterminate does not mean not defined. Indeterminate means it is something which you cannot determine. Not defined is infinity or minus infinity. Not defined means it is going towards either as great as possible or as low as possible. That also is something which you are not aware of, but this is as great as possible, that is plus infinity. As low as possible, that is minus infinity. But when we talk about indeterminate, that is like 0 by 0. Sir, in that case, we got it that 0 by 0 is indeterminate, but infinity by infinity should be 1. Don't you think so, sir? Infinity by infinity should be 1 because this infinity and this infinity will get cancelled, will be cancelled, by each other. The problem is, it is not that easy as you're thinking. Infinity is technically a concept of something which is unachievable, which is something huge. For example, right now I'm standing in a room. So this roof, this ceiling for me is infinity because I cannot reach it. I can just approach towards it. But right now, let's say with this height, I cannot reach it. So this ceiling could be treated as infinity for me. But for somebody, the sky could be infinity. Or let's say sun could be infinity. So For me, the ceiling and the sun both are infinity, but they are two different infinities. This infinity is slightly closer and that infinity is slightly farther. So you cannot compare two infinities. I mean, whatever written over here is, that is infinity upon infinity, but those two infinities are actually two different infinities. So come on, how can you talk like this? I mean, 2 or 2 are same, 1 or 1 are same. But trust me, infinity and infinity are not same. Infinity means a huge number. So this could be some other huge number, this could be some other huge number. And infinity is very subjective in nature. So what do you mean by very subjective? Let's say for me, sure, Vijay, don't worry. In that case, it will not be an infinity anymore. But sun will still be an infinity for me in that case. I repeat, let's say for me, 1,000 rupees are infinity. Let's say I hesitate a lot, let's say even in spending 1,000 rupees. But for my wife, 1,000 is like 0. For her, let's say 10 lakh is infinity. She may hesitate in spending 10 lakh. Are you getting my point? So it is very subjective in nature. It depends. I mean, whenever you compare two things, it depends. Let's say I want to say that 100 is huge. So I'll say 100 is huge with respect to 0.0001. But let's say if I say 100 is very small, yes, with respect to 1 crore. So the same number could be huge or small, and it is very subjective. With what are you comparing it with? So that's the point of infinity here, that infinity upon infinity is never one actually. This is some other infinity, this is some other infinity. So just not cancel it out and say one. No. So that's why we say it is again an indeterminate form. How, Mishra ji? Can you tell me? If both of them are same infinity, how will you figure it out? Infinity is merely a concept and imagination where you are just moving towards the greatest possible value. What is that greatest possible value? It's not a fixed number. That's the problem, Mishra ji. Yes, factorization, rationalization, and a lot of other methods which we are going to explore in the upcoming slides are the methods to work it out, all these indeterminate forms, which we'll definitely discuss slide by slide. And then we'll discuss continuity and differentiability. But right now, I'm trying to tell you a very straightforward fact that infinity upon infinity is not 1. So what is it? I don't know, which means we cannot find it, which means is it not defined? No. Is it plus infinity or minus infinity? No. Then it is indeterminate. We cannot find it. We cannot determine it. Yes, we cannot fix the infinity. How can you fix the infinity, Vijay? I used to have this doubt in my brain when I was in 4th standard. My classmates used to tell me that, we were taught counting, let's say in first class, we were taught counting till, let's say 20. In third, we were taught counting till 100. In, let's say 4th standard, we were taught counting till, let's say 1,000. In 5th standard, we were taught counting till, let's say 10,000. So for us, counting or the numbers stopped at 10, 100, 1,000 or 10,000 as per the classes which we were ascending. But even in 2nd or 3rd class, I used to think that how can the numbers, counting can be stopped? I mean, my friends used to discuss that 1 crore is the highest number. Somebody used to say that 1 million could be the highest. Some used to say 1 trillion. Some used to say 1 billion, depending on their awareness. But I used to always think that if I put one more zero, I'll get a bigger number. And that's my basic point regarding infinity as well. You cannot fix infinity. You cannot fix infinity. Because if you say that this is the infinity, I'll tell you just next to it, there is even greater number. So Vijay, we cannot fix the infinity. And that's the problem with infinity upon infinity. It is indeterminate. Infinity is a very beautiful concept. If you explore it, or if you learn about it, you will see a lot of beautiful things, which a lot of great mathematicians have already come up with. Sandy saying, sir, are we doing? Yes, we are doing expansions, Taylor, Maclaurin series, everything we'll do. Don't worry about that, Sandy. I'll show you a lot of questions based on those expansions, and we'll be doing them. And I'm sure in some of the questions, you will again tell me that, sir, can't we do it with L'Hopital? Yes, but I'll say use expansion. It's easier. And JEE will ensure that it will not allow you to use L'Hopital. Even if you use it, you'll fall in a trap that where you'll be, applying L'Hopital constantly or infinitely. An expansion or some other general technique will get you the answer very quickly. Have I made myself understood? Similarly, I hope nobody is thinking that infinity minus infinity should be 0. this is some other infinity, this is some other infinity. So I don't know the difference. So infinity minus infinity could be 0, infinity minus infinity could be minus infinity, infinity minus infinity could be infinity, infinity minus infinity could be anything actually. Sir, why? Because if this is something really huge, this is something very small, this is huge, or depending on what these values are. Sir, can we compare two infinities? Yes, depending on the case. You explore it or more on internet, you will get more idea about this. I'll come back to this discussion. Sir, come on. Whatever this number is, this is something huge. Whatever this number is, this is something very small. So something huge into something very small is 0. Sir, whatever this is huge plus infinity minus infinity, whatever it is, into 0 is 0. Yes. So infinity into 0 is 0. But actually, we are not looking them as infinity and 0. They are approaching infinity and they are approaching 0. Sir, what do you mean by that? I want to say that here, let's say if I multiply a very small number with, let's say, a very big number. So right now for you, let's say a very big number is 10, very small number is 0.2. So 0.2 is what? 2 by 10. And this is 10. So sir, it all depends that how big or how small that number is. Yes. So what I got was 2. And 2 is, let's say, still a very big number with respect to this 0.2. So let's say in the world of 0 and infinity, this is somewhere 0, this is somewhere infinity. Sir, what is the concept of infinity? Something very huge. So with respect to 0.2, let's say 10 is infinity. Just to make you understand this, I'm saying this, writing this. So here in this case, this was still approaching towards infinity. But sir, what if, let's say I take something very small as 0.000001 into, let's say I take something very big as, let's say, 1.23. So with respect to this, this is a very big number. So this is something close to 0 and this is something close to something very big. So something very big means what? Compare subjective. So with respect to this number is something very big. So it can be treated as infinity in this case. Just to make you understand this, I'm doing this. So in this case, the product would be really small. So sir, in the previous case, this 0 into infinity was approaching something very big. 0 into infinity in another case approaching towards something very small. So it all depends that this 0 is what kind of 0 and this infinity is what kind of infinity. Are you able to process whatever I'm saying here? I'm saying a simple fact that this is not exactly 0, this is not exactly infinity. These are not exact 0 or exact infinity. They are approaching 0 and approaching infinity. In the world of limits, they are the values which are approaching 0 and approaching infinity. So a value which is very close to 0 into a value which is very huge could be something very close to 0 or could be something really huge depending on how those numbers are placed or how those numbers are interrelated. So sir, if we cannot work it out, I'll say it is again an indeterminate form. Did you all get it? Are you all able to understand the concept of indeterminate form? Similarly, let's say if I talk about 1 to the power infinity. Come on, sir. No matter what, 1 to the power infinity is 1. 1 to the power 1, 1 to the power 2, 1 to the power 3, 1 to the power root 3, 1 to the power 1.7. 1 raised to any power is 1. So 1 raised to any big number. 1 raised to any big number is 1. Yes, I get it. But the problem is this one over here is not exact 1. Sir, come on. If it is not exact 1, why are you writing it exactly 1? Because in the world of limits, we are writing it as 1, but it is approaching 1. Sir, what do you mean by approaching 1? When I say it is approaching 1, 1 is approached from left-hand side raised to the power infinity. 1 is exact 1 raised to the power infinity. And 1 is approached from right-hand side raised to the power infinity. What does it mean? Let me try and clarify this. Let's say 1 is approached from left-hand side. So it could be something as small as 0.9, 0.98, 0.99, something like that, raised to the power. 1 is raised to the power infinity, but when is approached from right-hand side, it is like 1.1, 1.2, something like that, raised to the power infinity. And this is exact 1. So I'm trying to tell you the difference. A to the power x, when the base is less than 1. A to the power x, when the base is less than 1, is a decreasing function like this. A to the power x, when the base is 1, is a constant function like this. A to the power x, when the base is greater than 1, is an exponential function like this, Now, sir, why are you really teaching us this? Why are you really showing us all of this? Because when the power approaches infinity, a to the power x approaches 0. when, in this case, when the base is greater than 1, when the power approaches infinity, a to the power x approaches infinity. And if it is exact 1, in that case, if the power approaches infinity, it still approaches the same fixed value, which is 1. So 1 to the power infinity is 1. If it is exact 1. And the problem is, in this chapter, when we are talking about limits and continuity, we may probably deal with exact 1. Rather, I'll always deal with either something just slightly less than 1 or something just slightly greater than 1. So I'll be dealing with 1 to the power infinity, but 1 to the power infinity is not exact 1 raised to the power infinity. It will be something slightly less than 1 to the power infinity or something slightly greater than 1 to the power infinity. So are you again realizing we just cannot determine it? And if we cannot determine it, it is again an indeterminate form. Some people say that, sir, infinity into infinity is also an indeterminate form. Can you tell me whether this is an indeterminate form or not? Can you tell me whether it is an indeterminate form or not? It is, of course, not an indeterminate form. Imagine this is something huge, this is something huge. Something huge into something huge is something huge. So this is absolutely not indeterminate. Rather, it is not defined, or infinity you may call it. Absolutely, Shubham. Why should you not? If you're able to understand it, if you're able to get it, you must. You definitely should. So are you all understanding that these indeterminate forms are what, or kind of what? Like we have 0 by 0, 0 into infinity, infinity minus infinity, infinity by infinity, infinity to the power 0, 0 to the power 0, or 1 to the power. Now I'll discuss the different approaches for each of these cases. Absolutely. Absolutely. Good, Vijay. Keep it up. Really nice. Shall I move ahead from here? So I hope different cases you have understood. For example, let's say, sir, if we have 0 into infinity. So how do we solve it? This infinity, can I write as 1 upon infinity in the denominator? Because this infinity can be brought here again. But 1 upon infinity is 0. So this 0 into infinity, by some changes, can be converted into a 0 by 0. Because we'll often be able to deal with 0 by 0 very easily. Everybody got my point? For example, here, let's say I get infinity upon infinity. So I hope you to understand we have deliberately written as infinity 1, infinity 2. So I can infinity 1 can be this numerator infinity can be written as 1 upon infinity, and this denominator infinity can be written as 1 upon infinity in the numerator. So that's again 0, that's again 0. So this will become a 0 by 0 form. Sir, what if I have infinity to the power 0 form? What will I do there? Infinity to the power 0, what do we do there? So infinity to the power 0, if I wish to convert, let's say if I take log on both sides. So on the left hand side, it will be log y. So this 0 will be come to the front. 0 means it is not exact 0, it is approaching 0. And this will be ln of infinity or log of infinity. And log of infinity, what is it? Log of infinity, I hope you to remember, log of infinity is again what? Infinity. So this will be infinity into 0, and this infinity, I know how to convert into 0. So I will finally be able to convert it into a 0 by 0 form. Getting it, everyone? Yummy catering, I am not aware of that answer. So with this, I think 0 to the power 0 you're again understanding. I'll write it as log y. This will be 0 into log 0. So again, when I talk about standard log function, when the base is greater than 1, when x approaches 0, log approaches minus infinity. So it will be 0 into minus infinity. And again, this infinity can be written as 1 by infinity, which is 0 by 0. 1 to the power infinity can also be dealt with the same method. And again, I'll get this. So all these indeterminate forms can be solved. Whenever I'm having powers, I'll take logarithm. If I'm having infinity by infinity, 0 by 0, or 0 into infinity, I'll be using factorization, rationalization, L'Hopital, or some other methods which we'll explore with some time with the upcoming slides. Shall we get started with few questions so that we can get more clarity? So here we have one question, and I'll be hoping and expecting that you also participate and solve this question along with me. So while you're attending this session, keep a sheet, a pen and paper with you, and keep solving these questions along with me. Yes, we heard you. Good, great. Now, with this, shall we get started, everyone? Here we have limit x approaches 1 on this expression. And this needs to be evaluated. All right. So I can see it, I can sense it, that sir, if x is approaching 1, 1, 1, 0, 0, 1. What did I just say? I said a very direct, straightforward fact. I said a very direct and a straightforward fact where I said that here, if x approaches 1, this approaches 1. This is 1 into ln 1, which is again ln 1, which is 0 into 1, 0. This is again ln 1, which is 0. This is minus 1. So I hope you do realize 1 minus 1 is again 0. So the numerator approaches 0. Numerator, if x is replaced by 1, this is 1 minus 1. So denominator also approaches 0. So sir, what do you think? What can be done? I'll say that can I think of using factorization? How? Let's look for it. Here. This one. This x square n1, if I write together, so I'll be writing it as x square minus 1. Ln x, if I take common, so I'll have ln of x at base e, and this is again x minus 1. So this x minus 1 is actually multiplied with ln of x as whole. And sir, in the denominator, you have x square minus 1. Yes, we have x square minus 1. And there, x is approaching 1. Got my point, everyone? The moment you get the answer, I'll really appreciate if you could tell your answer in the poll here. So I have started a poll. This poll uses a feature, PyLens. PyLens is an application. If you install it on your phone or if you download it from Chrome Play Store, you will be able to participate in it. Or rather, if you are entering your correct answers in the comments, there also it will fetch it and it will accept those answers. So do let me know whatever you think of answer as an answer to this question. So here we have, if I take this x square minus 1, I hope we can write as x minus 1 into x plus 1. Yes or no? So this I can write as x minus 1 into x plus 1. So what I'm thinking of doing is, sir, x minus 1 can be taken common. So if x minus 1 can be taken common, if x minus 1 can be taken common, so this whole x minus 1 comes out and comes out as x minus 1. So this is what I'm left with. In the denominator, x square minus 1 can be written as x plus 1 into x minus 1. Getting it, everyone? So with this, I think I notice x minus 1 can be cancelled, because when x approaches 1, it is not exact 1. It is approaching 1 from either left or right. So when you're approaching 1 from either left or right, x minus 1 will be something very close to 0, but not 0. It will be something very close to 0 from left or from right. So it is something non-zero. So those terms in numerator and denominator can be cancelled. Brilliant, students. That's really good. Let's see that whether you write the correct answer or not. That's good with Sing Changs. What's wrong with your generation? Why do you guys keep your names like this? So here, what do we have now? So if I now substitute x as 1, this will be 1 plus 1, that's 2. This will be ln 1, which is 0, divided by 1 plus 1, that's 2, and 2 by 2 is 1. So your answer will be 1. Let's see how many of you got it right. So I'm stopping the poll and seeing the result. So 2 persons. I think Vijay, I don't know why your answer did not. Mishra ji, the people are getting answer as 1 by using this method which I have just shown to them. Have you gotten it or understood it? Good students with Ved and Sing Chang, however you pronounce your name. Sincerest apologies if I'm not pronouncing it correctly. But everybody, did you all get it? Any confusions? Shall we move towards the next question? This is again a very beautiful, very insightful and a very amazing question. Let's see how do we crack it. So what does it say? It says limit x approaches 3 pi by 4. Limit x approaches 3 pi by 4. The limit is 3 pi by 4. And the numerator is 1 plus 10x to the power 1 by 3. And denominator is 1 minus 2 cos square x. Okay, sir. Okay, great. This looks nice. So how do we solve it? Let's try and do it. So to do it, shall I again start a poll? But I don't know whether it will be a fixed number or not. Okay, Harshika, that's good. Good with Ved, that's brilliant. Mishra ji, okay, you got it. Brilliant, that's a good thing. Good sign, rather, I'll say. This one, again, of course, let's say if it is not found to be a fixed integer, then you simply write the closest integer. Okay, so here I'm again starting a poll. Let's see how many of you get it right. Don't use AI, please. If it is negative, write just positive part of it. So here we have this question. Can somebody tell me what is needed to be done? How are we going to solve this question? Okay, that's good. Shobha, that's good. Shubham, how are you getting the answer? Can you tell me your approach in the comments? I'll really appreciate it. If you could tell me, how are you really doing it? Anyone? How are you actually approaching it? By the way, sir, before we start solving it, what is your idea? What is your approach? I am saying, let's say if we try 3 pi by 4, what do we get? So numerator, 10 3 pi by 4. 10 pi by 4 is 1. 10 3 pi by 4 is minus 1. Cube root of minus 1 is minus 1. So this whole thing over here is minus 1. So 1 minus 1 is 0. So this numerator approaches 0. Similarly, cos 3 pi by 4. Cos 3 pi by 4, whether it is 1 by root 2 or root 2, sorry, 1 by root 2 or minus 1 by root 2, and it is squared, it will be 1 by 2. 2 and 2 are cancelled. So this whole thing is again 1. And this 1 minus 1 will make it 0. So what are we noticing over here is through observation only, sir, we are seeing it to be a 0 by 0 form. Everybody got it. Everybody noticed it. Everybody understood it. Now you tell me, how are you getting this answer minus 1 by 3? Shubham and everyone, those who have gotten it. So sir, how are we really going to do it? How are we really supposed to solve it? What methods do you think can be applied here? Shall I now at this stage use or tell you the L'Hopital rule? Although you could do it with, let's say, rationalization. But I'll suggest you that instead of using any trigonometric identity or something like that, don't worry. Where I have simply put x is equal to 3 pi by 4, with the help of which I got this as 0 and the denominator as 0. So now, with your permission, if I bring L'Hopital into picture. So L'Hopital was a French mathematician, where H is silent here. So L'Hopital said something really beautiful, that whenever you encounter either a 0 by 0 or an infinity by infinity form, then the methods which you know already are factorization, rationalization, and a lot of other methods. But other than that, you can use L'Hopital as well. Now, what is L'Hopital? L'Hopital says differentiate the numerator, find the derivative of the numerator, and differentiate the denominator. And then apply the same limit, and it will give you the answer. So what if we don't get a finite value? What if we again get a 0 by 0 or infinity by infinity? Then again apply L'Hopital. Apart from L'Hopital, what other approach can you have? Can somebody tell me that, sir, despite using L'Hopital, you could use this method as well? Anyone? Although there are multiple ways, trigonometric limits also could be applied, but I'm avoiding that because we have not learned it right now. No, Shubham, you don't use U by V rule. No. L'Hopital means differentiating numerator separately and differentiating denominator separately. It does not mean you are applying quotient rule on this expression of derivation. No. That's not what you should interpret L'Hopital as. Shubham, did you get my point? So I'm coming back to the discussion, everyone. I am saying if I directly apply L'Hopital, I think you understood this. Or fraction form, how? I mean factorization of fraction with, what are you exactly saying? What are you exactly suggesting here? Anyways, if I apply L'Hopital, what does L'Hopital say? Sir, differentiate numerator. So derivative of 1 will be 0. 1/3 of 10x. 10x raised to the power 1 by 3. Chain rule, I hope you're aware of. Sandwich, really? How, Mishra ji? Can you really think of sandwich on this expression? Don't even think of doing something like that. So 1/3 of 10x. 10x raised to the power 1 by 3. When differentiated gives you 1 by 3 into 10x to the power 1 by 3 minus 1, which is minus 2 by 3. So can I write it as here in the denominator 10x to the power 2 by 3. Did you all get it? Whole divided by. Anyways, as per chain rule, 10x also should be differentiated. So derivative of 10x is sec square x. So this is my final derivative of numerator. Chain rule I have applied. Everybody got it? Any confusions? Good, Vijay. Now, along with this, whatever approach or method you are using, keep telling me your approaches or ideas. Apart from L'Hopital, if you have used some other result, factorization or rationalization or some other method, do let me know, whatever you're doing here. With this part, if I bring or talk about the denominator part, again, derivative of 1 is 0. I'll have minus 2. But chain rule, if I use cos square x will be 2 cos x, yes or no? And derivative of cos x is minus sin x. So it will be sin x like this. I hope everybody got it, understood it without any confusion. And there again, you're putting limit x approaches 3 pi by 4. Any queries, confusions, or concerns if you have, please ask. Yes, RHN and LHL also you can apply, but what is the point of doing it right now? I don't see any problem with LHN and RHL right now. LHN and RHL, Shubham, should be brought mostly when you're dealing with GIF, modulus, fraction, signum. They actually bring more of this LHL and RHL. There more of LHL and RHL happens. In these cases, you really don't bother much about LHL and RHL. Got my point? Now, let me take it further. How do we solve it? I hope differentiation part you have understood. More importantly, I was trying to explain L'Hopital with this question. Have you all gotten it, or shall I repeat it? What did I do? If you are confused with L'Hopital, whenever we get 0 by 0 or infinity by infinity, we differentiate numerator separately and we differentiate denominator separately. So differentiation of numerator, differentiation of denominator, 1 by 3, 10x to the power 1 minus 1 by 3, which is 2 by 3 in the denominator, and then 10x is sec square x. And here, minus 2 cos x, and cos x is minus sin x, so it is plus. Everybody got it? Now, if I rearrange it, what do I get after final rearrangement? Let me write that part as well. Sec square x, just for the simplification, can I write here as 1 upon cos square x? And this thing, if you are not getting, I'll write 1 here, so that when you swap it, it all simplifies as 1 by 3 into 2 into 2. So I'll get 1 by 3 into 2 into 2. But then the other expression which we receive is sin x, which is sin x, then 10x, which is 10x, but 10x to the power 2 by 3. And then cos square x and cos x, that is clearly cos cube x. Everybody comfortably got it without any confusion. Okay, Kamini Rajput is saying, sir, it is 0 by 0, not indeterminate it is. It is not defined, it is indeterminate, as we have just learnt. And with that, I hope you do realize and understand that there is a problem, that here you can apply either factorization or rationalization or L'Hopital as we have just explored. Everybody got it. So 3 into 2, 6, 6 into 2, 12. So I'll first of all get a 1 by 12 over here. But sir, what about this part? Can you really simplify this part? Let's try and do it. So what do we have here is 10x to the power 2 by 3. That 10x to the power 2 by 3, can I write as sin x to the power 2 by 3 divided by cos x to the power 2 by 3. Everyone comfortably getting it? Any confusion? Yes or no? Now what I do next is, please pay attention everyone here. Sin x, what is it? Power 1, power 2 by 3. So what does it give you? So it gives you what? It gives you sin x to the power, I mean power doesn't really matter, even if I just put the final value. What final value? 3 pi by 4. I would have gotten the answer. So shall I directly put the final value without even, simplifying it? I think that will do the more simplified version, or give me the more simplified version. So here we have sin 3 pi by 4, tan 3 pi by 4, and cos 3 pi by 4. If you simply put these values, you will get the answer. Are we done? I repeat, if you don't know it, I'll do it for you. Here, I am asking you 3 values: sin 3 pi by 4, which is pi plus pi by, pi minus pi by 4. I am asking cos 3 pi by 4, which is cos pi minus pi by 4. I hope you're getting it. And I'm asking 10 pi 3 pi by 4, which is pi minus pi by 4. Some of you were asking me this in the comments, that how did I get it? This is how you do it. I hope it's easy, simple, and doable. With this sin pi, I hope you know this quadrant theory, which you must have studied in 11. Pi minus. So pi does not change the ratio. It is still sin pi by 4 with a positive sign, because it is in the second quadrant. But this will be minus cos pi by 4. This will be minus 10 pi by 4. That's exactly what I was saying, that this will be 1 by root 2. This will be minus 1 by root 2. And this will be simply minus 1. So if I simply substitute these values, here we have 1 by 12 times whole of sin x is 1 by root 2. Cos x is 1 by root 2. I mean minus 1 by root 2. Cube is again minus 1 by 2 root 2. And there, this is -1. Square is 1. 1's cube root is 1. So that is 1. Everybody processed it, understood it. Any queries or confusion? And I think now you can simplify and get the answer, which is simply what? 4. Yes or no? But 4, 3. So -1/3 is your final answer. I hope it was easy, understandable, completely. And I'm sure some of you must have gotten this. -1/3. Yes or no? Everybody. Let's quickly check how many of you got it. Of course, -1/3. If I just take positive part of it as 1/3, 1/3's closest value is 0. So why did I start a poll like this? I'm really sorry. A poll should not be started like this. I'm really sorry. I am really sorry. So it should have been an integer type. Anyways, everybody got 1/3, -1/3. Good, Harshika. That's good, Vijay. It's not 1/12, Vijay. It's 1/3, -1/3. You can, but what's the point of simplifying it, Shubham? You can simply put the values and get the answer. Got it, everyone? Everyone? Shall I move ahead from here? Now let's try the next question. Again, a very good one, a very insightful one, and a very interesting one. How do we solve this? Let's focus on it. It says n is approaching infinity. So whenever you get infinity, definitely Miss Kamini, you can. So here, whenever you have infinity, you try to take something common so that it approaches 0. It approaches 0. How? Let's talk about that. So if I take 5 to the power n common from here, why, sir? Let me just do it. So it will be 4/5 whole raised to the power n. 5 to the power n by 5 to the power n will be 1. And when 5 to the power n comes out, it will be 5 to the power n to the power 1 by n, which is 5. And this whole thing is raised to the power 1 by n. And their limit n is approaching infinity. Can I rewrite this whole question as this? Did you all get it, or shall I repeat it? Absolutely. A very good suggestion you have given, Mr. Vijay. Beautiful. Keep it up. Really nice. Now with this, if I simplify this, what do I get here? Sir, when n approaches infinity, 4/5 is less than 1. So when something is less than 1, a to the power x, when you draw the graph, and the base is between 0 and 1, this is how it goes. So when the power approaches infinity, the expression approaches a value 0. Getting it or not, everyone? So I hope you got it. This expression, when power n approaches infinity, this 4/5, since it is less than 1, this 4/5 will be approaching 0. 4/5 whole raised to the power infinity. So this whole thing is 0 plus 1 is what? 1. Yes or no? So it is like 5 into 1 to the power what? 1 by infinity, which is 0, which is again 1. So my answer will be 5. Absolutely, Vijay. That's brilliant. With the answer is not 0. The answer will be 5. I think 0, you're answering or referring it to this or this. Yeah, that's cool. Good evening, Miss Jagrati. Good to have you here. I hope everyone is listening and understanding. How did we get 5 as the answer? Let's see how many of you got it correctly. And let's see how many of you have genuinely found the answer. That's good, Harshika. That's good, Vijay. And we have RRK as well, who got the answer in 39 seconds. Unbelievable. Great. Excellent. Everybody understood it without any confusion, query, or concerns. Shall we move ahead from here, all the participants? All the participants now. Through rationalization, how do we solve? Let's talk about that idea as well. Everybody. Yes, Mr. or Miss Kaur. Hello, hi, namaskar, everyone. Let's focus on the concern now. This part. When x approaches a, they are specifically telling you that a is not 0. What is the answer? Give me a moment, students. Give me a second. Give me a second. Let me have some water and then we'll start. By the way, by the time I answer this question, you can also try and answer this question. Type your answer or write your answer in the chats. Okay, so we have Gaurav sir among us. You are very on Gaurav sir. Gaurav sir of chemistry, Mr. Math Virat Kohli. So Thalaiva, we call him Dhoni, the boss. He is telling me to tell you all to join tomorrow for chemistry live. So it is Sunday tomorrow. Don't be in a holiday mode. So Sunday, that is tomorrow, you will be having a chemistry live. So could you tell us the time as well? At what time will it be? So yes, they will be bringing a lot of questions for stereoisomerism. So I really appreciate, and we all really appreciate if you do attend it, because he'll be bringing a lot of advanced level problems in that session. And as we all know, chemistry is the subject which works as a, decider. So be all there, everyone. Definitely, everyone can watch this session as long as you're attending and watching and understanding it. Good to have you people from the Laksh batch. No, it's not question practice, Jagrati. It is complete revision of your entire LCD, limits, continuity, and differentiability. Yes, Miss Rajput, you can. Definitely you can. Has anyone done this question? Has anyone solved this question? Okay, everyone. So shall we resume? Shall we all focus? So it says x is approaching a. So sir, why don't you simply push a? So if I push a here, I think you get the answer. The problem is 2a plus a, that's root 3a. Root 3a, root 3a, that's 0. 3a plus a, that's root 4a. That is 2 root a. 2 root a, 2 root a, that's again 0. So sir, it leads you to a 0 by 0 form. So sir, shall I apply L'Hopital? Please. You don't always have to apply L'Hopital. Don't be obsessed with L'Hopital. Absolutely, Jagrati. Good observation. So the better practice here would be rationalize. Sir, how? I think you know rationalization, don't you? So rationalization here says, I hope you know the rationalization. This will be multiplied with its conjugate in the numerator. So I hope you do understand, when a minus b is multiplied by a plus b, can I directly write the final product, which is a square minus b square? I hope that one step we can skip. Good, Vijay. You have come up with the answer. That's brilliant. So this will become a square minus b square, which will be a plus 2x minus 3x. Yes or no? In the denominator, a minus b into a plus b will again be a square minus b square. So that will be 3a plus x into, minus 3a plus x minus 2 square. I hope you're understanding. Square of 2 will be 4. Square of root x will be x. So this is what I'll get in the denominator. But sir, you're forgetting balancing it out. You multiplied the numerator by its conjugate. So it should be there in the denominator. Yes, I should bring it. So its conjugate, the numerator's conjugate is a plus 2x inside and under root plus root 3x. That should be written in the denominator. And the conjugate of the denominator should be written in the numerator to balance it out. So in the numerator, I'll be writing it as root over 3a plus x plus 2 root x. Everybody got it. Everybody understood it. One step I have skipped just to save some time, and this is exactly how you should also do it whenever you're preparing for ITJ. You should try and save time, so that as less as you write, as more time you save. The more you write, the more time you consume, right? The more time you waste. So here in this case, of course, limit was what? Limit x was approaching a. So in this case, what happens here is, sir, this is 2x minus 3x. How much is that? That's minus x, I believe so. Yes or no? So it will be a minus x technically. It will be a minus x. So what happens in the denominator? That's again what? 3a and x minus 4x. That's minus 3x. So this will be 3a minus 3x. So sir, again you can take 3 common from here. So when I take that 3 common from here, it again leaves me with a minus x. Everyone getting it? So this a minus x are cancelled. So ultimately you're left with 1 by 3, aren't you? I think you're simply left with 1 by 3. Okay, sir. So what have you achieved by doing it? Let's see that. So when x is replaced by a, this is 3a plus a, which is root 4a. That is 2 root a. Getting it, everyone? This is also 2 root a. So 2 root a is 4 times root a. I hope you are understanding it, everyone. Denominator, a plus 2a, that is root 3a. So that is 2 root 3 times root a. Can I write that root a separately? And that was already a 1 by 3 here. So this root a are nullified. 2 is 4. So this should be 2 by 3 root 3. This should be 2 by 3 root 3. Did I really start a poll here? Oh, I did. Fortunately. Great. And this will be the answer. How many of you got it? That's good, Vijay. Good, Jagrati. Good, Shubham. That's brilliant. Keep it up, students. Keep it up. Brilliant. Keep it up. Really nice. I hope you're getting it comfortably. You're understanding this concept now. Yes or no? Now, this is a very beautiful concept. This is a very amazing concept. And for this, we tell students to remember a short trick. First of all, there is a polynomial in the numerator. There is a polynomial in the denominator. So as long as there are polynomial upon polynomial where the variable is approaching infinity, for you it is simply infinity by infinity form. But sir, numerator has what infinity, denominator has what infinity? Can you help us in guessing that? Okay. So I'm bringing some cases, bringing some scenarios so that you can get it. Let's say in the numerator, you have 4x cubed minus 3x square plus 2x plus 5 whole divided by, let's say 2x plus 3 or 2x square plus 3x minus 5, where x is approaching infinity. Where x is approaching infinity. That's the case. I'll explain this case with two methods. So let me bring few more cases. Now the next case, where let's say in the denominator, instead of a cubic, you have a biquadratic, something as 6x to the power 4 minus 3x cube plus 5x square plus, let's say 6x minus 9. This is one of the cases. Let's say there's one more case where both degree of the numerator and denominator is same. So if degree of numerator and denominator is same, let's say it is like this. Getting it, everyone? I hope you got it. So there is one more case. There is one more case where let's say degree of numerator and denominator is same, but let's say the sign is same of the highest degree terms coefficient. Okay, this is also one of the cases. Sir, can there be some other case? Let's keep these cases now. First of all, let's talk about this case. As I have already tried mentioning this to you, good students, keep it up, really nice. Here in this case, good, that's very good, Vijay, that's brilliant, that's really nice. I hope everybody is clearly noticing that, sir, here, numerator is cubic, denominator is cubic. So the rate at which it is approaching infinity are same, or minus infinity is same. So my simple observation is one of the ways which you use in boards is you take x, or rather highest power of x, which is x cube common. So when you take x cube common, how does it look like? Imagine I'm dividing numerator and denominator both by x cube. So what happens in that case? So if I divide both numerator and denominator by x cube, this becomes minus 4. This becomes minus 3 by x. This becomes 2 by x square. And this becomes 5 by x cube. Yes or no? This is how you're supposed to do it in boards. Similarly, x cube I'm taking common from the denominator, so it becomes minus 3. It becomes 5 by x. It becomes 5 by x. And this becomes 6 by x square. Yes or no? And this becomes minus 9 by x cube. Sir, why have you really done it? Have patience, as I'm constantly telling you, whenever x approaches infinity, I'll prefer to have it in the denominator. Sir, why? Because 1 upon x, when x approaches infinity, is 0. So the advantage is really simple. That when x approaches infinity, 3 by x, 2 by x square, 5 by x cube, 5 by x, 6 by x square, 9 by x cube, they all will approach 0. So I'll be left with minus 4 and minus 3. So my answer will be minus 4 by minus 3, which is 4 by 3. Sir, but do we really have to do it? Have you not seen the pattern that, sir, you really don't have to do it like this? The moment you notice something really beautiful, something really interesting, something really straightforward, that numerator and denominator have the same degree. If numerator and denominator of the same degree, and if the x is approaching infinity, then your answer will be ratio of the coefficients of the highest degree term. Did you all get it? Did you all understand it? I think Shubham is saying something. Observe the term which approaches infinity, because other exponent does not contribute to the limit. If same degree, take a ratio. If numerator has more degree, infinite. Absolutely, Shubham. That's exactly what I'm trying to teach you all here. That's a very good observation. Very good, very brilliant observation. So I hope, can you tell me the answer in this case? Don't worry, boss Harshit. Don't worry. I'll tell you again, don't worry. I am saying that if numerator and denominator have the same degree of polynomial, where the variable approaches infinity, then a very beautiful, I don't call it short trick, some people call it, so let me also call it, because I want to be like them. Short trick says that the answer will be this 4 upon minus 3. So in this case, answer will be minus 4 by 3. That's it. Boss, hush it. Everybody got it? Or shall I re-explain this? Now, what will be the answer in this case, students? Again, the one of the methods is you simply take x cube and x to the power 4 common, or rather you divide both numerator and denominator by x to the power 4. So ultimately, do you realize that if you do so, let me do it here so that you get it more clearly, but you really don't have to do it. Please understand, this and this both will approach infinity, but the rate at which this will approach infinity will be a little higher. So this will be infinity upon infinity, but this infinity will be greater. So this will be approaching 0. So you can directly write the answer as 0. What did I just say? If the numerator and denominator have polynomials where degree of polynomial in the denominator is greater than the degree of polynomial in the numerator, then your limit will be approaching 0 if x approaches infinity. If you don't believe me, just do one thing. What? Take x to the power 4 common from numerator and denominator. You will see it coming. You will see it coming. You will notice it coming. Will you try it by yourself? All the participants, yes or no? Okay, sir. Then what happens in this case? Again, I'll suggest you to do one thing. Just divide both numerator and denominator by x square. When you do it, just divide both numerator and denominator by, let's say, x cube. Just take x cube common from the numerator and denominator. So, sir, numerator has a degree 3, denominator has a degree 2. So, if the degree of numerator is greater than the degree of denominator, then the answer is infinity. It approaches infinity. Infinity if coefficients both are positive or both are negative. If this is positive, this is negative, it will be minus infinity. If this is positive, this is negative, it will be minus infinity. And logic, you all know. Everybody got it? Everybody understood it? So let me just put this case here, that if it is minus 4x cube upon 2x square, cubic, quadratic, numerator degree is more than denominator. Definitely, Shubham, I'll do it, don't worry. So it will be approaching infinity, but minus infinity. Negative on positive is minus. So it will be approaching minus infinity. Yes or no? So there we have a question. It does not have any options, unfortunately, but I hope that it will have an integer value as an answer. But even if you not get an integer, just write the closest integer to it, right? Round it off to its closest integral value. I'm not asking you to take the GIF, I'm asking you to do the rounding off process because we don't have options here. Shall we do this question, everyone? Here we have this question. Can somebody tell me how are we really going to solve it? Anyone? Sequence and series is being used here in this question, if you notice. How? Anyone? Can you write the hint or the idea which is getting applied here in this question? Anyone? Can somebody tell me what logic is being used? I hope everybody has noticed in the numerator 1 cube, 2 cube, 3 cube till what? N cube. What is this? Sir, this is sum of first n natural numbers cubes sum. So sum of the cubes of first n natural numbers is given by n plus 1 divided by 2 whole square. So that's your numerator. What is happening in the denominator? Sir, it is under root over 4n raised to the power 8 plus 1. And there limit n is approaching infinity. So I hope some of you must have already cracked the answer by looking at this step. But if you are still feeling confused, just follow the process. Sir, what process? Just simplify this. Numerator, n plus 1. So n is n, which is n squared technically. N plus 1 when squared is n squared plus 1 plus 2n. Everybody got it? Whole divided by 2 square, which is 4. Can I write that 4 here? And inside it, I'm still having what? 4n to the power 8 plus 1. Now what, sir? Now what? Okay, everyone got this part. Any confusion? Some of you, I think, must have understood it. If you're still feeling confused, let me take it further. Let me take it further. Although you really don't have to, but still, if you want it, we can do it. N square when multiplies in the numerator, it is n to the power 4 plus 2n cube plus n square. Getting it, everyone? And in the denominator, shall I do one thing rather than doing it like this? Can I take n to the power 8 common from denominator? Can I really do it? I hope you are getting it, everyone comfortably understanding it. So n to the power 8 when comes out from the denominator, it comes out as n to the power 4. So this is 4 n to the power 4, and inside here, you're left with 4 plus 1 by n to the power 8. Sir, why are you taking this common? Because n is approaching infinity. I'll prefer to have it in the denominator. Absolutely, absolutely, Vijay. Good, Shubham. Let's see, what do you get as an answer? Everyone, that's great. That's brilliant. So in the numerator, if I'm taking this one more n square common, so n square will be n to the power 4 outside, but here it will be 1 plus 1 by n square plus 2 by n. Although you really don't have to do it like this if you know the logic, if you know what the short trick says, which we have just learned and applied. And I'm sure everybody now must have cracked the question that, sir, here, this and this are cancelled. This 4 is 4, which is simply 4. But this, when approaches infinity, this will approach 0. This will approach 0. This will approach 0. So this will be 1. This will be root 4, which is 2. 2 into 4 is 8. So my answer will be 1 by 8. And 1 by 8 is very close to 0. So we are supposed to write the integer answer. So I'll say answer will be 0. Although the answer is 1 by 8. If you have written 1 by 8 in the comments, you're good. You're going great. Are you really studying for BCA, Shazyan? With this, I don't know. Is it really asked in BCA? I'm not aware of it, but good. Good, Shubham. That's brilliant. Good, Vijay. Good, Harshika. All the other students, have you gotten 1 by 8 is the answer? So if you have gotten 1 by 8 as the answer, I'll say 0. Rounding off will give me 0. So with this, I'll stop the poll. Nobody, I think you all have done it, but we are not getting it because you have not written 0. But I hope you are getting it. 1 by 8 is the correct answer. Everyone got it? Any confusions? Shall we bring few more questions? This is a very good question, a very beautiful question. If you could tell me the answer, I'll be really happy. If you could genuinely, without cheating, tell me the answer. One of the questions, any one of the questions, if you could tell me the answer, I'll be really happy. Anyone who can tell me the answer. If you are thinking that answer is, if you are thinking that answer for this question, let's say is, let's do it, everyone. Let's do it. So, sir, what are we asked? What is happening? What are we asked? Let me solve the first question here. This one I'm solving. So fx is defined as this. Okay, x is approaching infinity. So when x approaches infinity, on x square minus 3x plus 2 divided by x square minus 7x plus 12. So sir, we know the answer. Coefficient of x square, because degree of numerator and denominator is same. So this whole thing is actually 1. So sir, we know the answer. Actually, it is sine inverse 1, and sine inverse 1 is pi by 2. What if I say that this is wrong? Why? Why? Why is this wrong? Why is this wrong? Can somebody quickly tell me why is it wrong? Little stars, I'll definitely tell you whenever we do integration, I'll definitely tell you. But I'll give you the hint. You just use integration by parts, integration 1 into ln x. First function, second function, if you apply, you'll get the answer. No, it is not pi by 2 with Ved. That's the problem. Yes, Shubham, will do in future, definitely. But right now, let's focus on what everybody needs. Let's work for a greater cause, for a better cause, for a better purpose. So I am saying my job is actually to figure out that this expression is approaching 1, but from which side? If I could try and help you, let me just draw the graph of sine inverse x. So I hope you do remember sine inverse x has a graph like this. So when you see it, when you see 1, it is pi by 2. So I hope you do agree that sine inverse 1 is indeed pi by 2. But if 1 is approached from left hand side, then only we say it is pi by 2. If 1 is approached from right hand side, I don't see the existence of the function. So how will I say pi by 2? Right will be RIGHT, my little stars. So here comes the next part. That, sir, how do we work it out that this expression is approaching 1 from either left side or right side? How? Okay. Let me see that what I know is that, sir, we know that this is approaching 1, but whether from left or right, that I don't know. Yes. So what if for a while, I try to work out what is fx minus 1? What is fx minus 1? Okay, let's try and look at fx minus 1. So fx minus 1 is going to be x square minus 3x plus 2 whole divided by x square minus 7x plus 12 minus 1. So this when simplified looks what? Looks what? I hope you are realizing x square minus 3x plus 2. Then it will be minus x square plus 7x minus 12. Correct me if I'm wrong. Whole divided by x square minus 7x plus 12. Getting it, everyone? So there, sir, we notice that this x square and x square are cancelled. Yes, they are cancelled. So I am left with minus 7x minus 3x, which is 4x. So this gives me what? 4x. Yes or no? And then minus 10 whole divided by x square minus 7x plus 12. Everybody got it? Sir, why have you really done it? Have patience. I'm going to tell you something really interesting. Limit x approaches infinity on fx minus 1. What would that be? So that would be limit x approaches infinity on this. So limit x approaches infinity on 4x minus 10 whole divided by x square minus 7x plus 12. What would that be? Sir, both are polynomials. This is linear, this is quadratic. Linear upon quadratic approaches 0. So this thing is approaching 0. This thing is approaching 0. So what do I know here is that limit x approaches infinity, fx minus 1 is approaching 0. Yes or no? Yes or no? A lot of students are saying a lot of things. Jagrati, Sudarshan, India, I don't know this. Sir, I will watch this 2x after this completed, because yes, you have completed in batch, in the Laksh batch, of course. Definitely. You can definitely prepare and solve more PYQs. Shubham has already answered it. Vijay, you are still mistaken. With Ved, you are still mistaken. Again, go through it one more time. Yes, Shubham, you got it right. But you tell me that here, this is approaching 0, but 0 from what side? Is it positive 0 or negative 0? Sir, 4x minus 10 will be something. I hope you are realizing. X square minus 7x plus 12 is something. I hope you are realizing. It is, of course, approaching 0, linear upon quadratic. But are you not realizing that around 0, right on the right or left of 0, if you notice 4x minus 10 upon x square minus 7x plus 12, you will see that this is slightly greater than 0. What did I just say? And how do we prove it? Let's talk about it. First of all, did you all listen to me? Did you all listen to me? Give me a second. Everyone, just hold on for a while. I'll get few elements removed so that we can focus. Vijay, mouse. So, okay, great. Here we are. All I'm saying is that this expression is going to be greater than 0. Did you all get this? So if I am saying that this expression is greater than 0, I am saying that limit x approaches infinity, f of x is indeed 1, but it is approaching 1 from the right hand side of 1. No, Vijay, the answer is not 1. Why are you not understanding? Everybody getting it? Everybody understanding it? Yes or no? Or shall I repeat it? This part specifically, that this is indeed approaching 0, but from the right hand side of 0. If you just put any value, you will notice that it is, let's say you put any value. Let's say if you try any value, any great value, x is approaching infinity. So any great value, any huge number if you put here, you will notice that this will be positive on positive. So it will be approaching 0 from the right hand side of 0, which means it will be very small, but from the positive side of 0, from the right hand side of 0. So I'm saying fx minus 1 is approaching 0 from the right hand side, which means it is positive. Slightly greater than 0. So fx, when x approaches infinity, will be 1, but slightly greater than 1 in terms of limits. I think we got it. Now the problem is, if I apply that thought here, when I'm asked to solve sine inverse of something slightly greater than 1, So sine inverse 1 is pi by 2, but sine inverse of anything greater than 1 is not defined. It is not defined. It does not exist. Yes or no? It clearly does not exist. So what will be your answer? Does not exist. That's good, Shubham. Vijay, did you get it? All the other participants who are watching it sincerely, have you all understood it, or are you feeling confused? Did you all get it? Shall I move ahead from here? Second part, I'm giving you as homework. I hope you all will try this at your home and will tell me the correct answer. Everybody, yes or no? Exactly, Vijay. Good. Keep it up. Homework, sir, how are we going to solve? I mean, are we going to have this PDF? Yes. You can have this PDF if you are watching it and seeing the comments. There is a pinned comment, which is taking you towards our free batch. We have a free batch for JEE with these one-shots where we are uploading these PDFs in the free batch. You can have those PDFs. You can revise these one-shots with those PDFs. You can solve the questions, solve the homework questions, revise the good questions, and definitely ask the doubts anytime, whenever you want. 24/7 doubt support system. Which I think I have told you, didn't I? I am saying that you try any positive value, any, because x is approaching infinity. So you give it a huge number. Let's say try x as 100. So 100 minus 4 is something huge, minus 10 is something positive. At 100, this denominator is also something positive. So positive on positive is positive. So it is approaching 0, but from the positive side. No. There is no other method, but just through observation, you can work it out. Shall we try this question, everyone? Can you tell me the answer in the comments? Everyone, are you all set? Are you all ready? X is again approaching infinity. This upon this and this. Okay, sir. I think this question can be done with the help of intuition. Yes or no? Here again comes a very beautiful and very interesting question. You tell me, how do we do it? Everyone, please pay attention. Here in this question, sir, I hope everybody is noticing that if I solve these two parts separately, the base and then the power. So everyone, please pay attention. When I talk about the base, it is quadratic in the numerator, quadratic in the denominator. So I hope you do realize when x approaches infinity, it is always a ratio of the highest degree terms, which is 1 by 3. Yes or no? Which is 1 by 3. Now here, this is again something polynomial upon polynomial, but degree of numerator is greater than degree of denominator. So if degree of numerator is greater than degree of denominator, it approaches infinity. So it is 1 by 3 to the power infinity. I hope I need not tell you. 1 by 3 to the power infinity is like this. This is the graph of 1 by 3 to the power x. So if x is approaching infinity, I hope you're realizing 1 by 3 is clearly approaching 0. So this answer you could have directly said or stated had you been aware of these basic things. How many of you could crack it? How many of you were able to think like this? Which I think I have answered that query, didn't I? Why are you constantly asking the same doubt? Everybody got the answer. That answer will be 0. How many of you were able to crack it? Tell me honestly, students. Shall I move ahead from here? Now, there is a very standard, very crucial, very important result which you can explain with the help of absolutely easy. No, with Ved, it's not 1 by 3, it's 0. Solve it completely. I hope binomial expansion you have studied in 11th standard. Even if x is very less than, small, which is less than 1. Good, Harshika, that's brilliant. We can neglect or remove the higher powers of x, and I can write 1 plus x to the power n as 1 plus nx if x is a very small positive quantity. Do you remember that? Do you all remember that? Yes or no? So I hope you do remember it. So based on this result, we come to a conclusion that x to the power n minus a to the power n upon x minus a. This is technically a factorization. I hope you do remember that factorization as well, that you have learned it, that x to the power n minus a to the power n is actually x minus a is equal to, x minus a into x to the power n minus 1 plus x to the power n minus 2, a to the power 1, plus and so on until we keep reducing the powers of x, increasing the powers of a. Ultimately, x power reduced to 0 and a's power is raised to n minus 1. So that's how you write this. Okay, Vijay, I will. Don't worry. But let me get done with this part. So if I take this x minus a here, I get x to the power n minus a to the power n as, or upon x minus a as here, x to the power n minus 1 plus x to the power n minus 2 into a to the power 1 plus x to the power n minus 3 into a square, and so on until x to the power 0 and a to the power n minus 1. Sir, why are we really discussing it? Because if you apply limit x approaches a, so this will be 0 by 0. But actually it is not 0 by 0. It is a to the power n minus 1, a to the power n minus 1, a to the power n minus 1, a to the power n minus 1. How many times? N times. So it is actually a to the power n minus 1 added n times. Also it is n times a to the power n minus 1. Yes or no? So this looks like a derivation based or a kind of a formula, but I'm sure you are not going to forget it anymore and you will indeed remember it. Again, a very crucial and important result, which you should directly remember to be applied in JEE just like that. Vijay is asking for the previous question to be repeated. The previous question was absolutely simple, Vijay. All I did was nothing, but I said a very straightforward, direct idea where I told you to apply the basics. The basics you know. So what basics? This is quadratic upon quadratic, x is approaching infinity. So answer will be coefficients of highest degree terms, which is 1 by 3. This is quadratic upon linear. So quadratic upon linear means infinity. Remember that? Plus 3 upon 1. But positive 1 positive is infinity. If numerator upon denominator have, numerator has higher degree. So it is looking like a question where 1 by 3 is raised to a huge power. So this is a very small number. And if a very small number is raised to a huge power, it approaches 0. That's what I told you. Are we clear on this? Any confusions? Shall we now focus on the next question? Everybody, could you again tell me the answer in the poll? We had started the poll. So here it is. It is going on. Shall we? Everyone, are you all set? Are you all ready? Everyone participating, listening, learning, and understanding. Yes or no? So what does it say? Here it says that x is approaching 2 and you have x to the power 10 minus 1024, x to the power 5 minus 32. Okay. What I'll do here is x to the power 10 minus 2 to the power 10 whole divided by, can I write it here? X to the power 5 minus 2 to the power 5. Quickly tell me, can I do this? Can I do this? Now, one thing I wish to do here is that can I write x minus 2 here in the denominator and can I write x minus 2 here in the numerator? Because this and this are cancelled, so it is absolutely doable. So I did apply limit there in power. Did you not notice, Vijay? I did apply it. I'll explain it anyways, but have patience. Let me get done with this question. So I hope would you accept that here x to the power n minus a to the power n upon x minus a. What is that? Sir, that is n, which is 10 into a, which is 2 to the power n minus 1, which is 10 minus 1, which is 9. Sir, here, this upon this is again that x to the power a minus a to the power n upon x minus a. That is n a to the power n minus 1. Where x approaches a does not make any sense because it is constant clearly. So 5 and 10, that's 2. Yes or no? 9 and 4, that's 5. So that's 5 plus 1, that's 6. So 2 to the power 6 is 64. And this would have been the answer. How many of you got it? How many of you understood it? Has everyone realized it? Has everyone gotten it? Everyone comfortably understood it? That's good, Vijay. 50%. So who got it wrong? Shubham, what's going on? 5120? Come on, how? How are you getting 5120? Really? Yes, Shubham, that will be 64. The previous one, I think I have explained it, Vijay. Just go through it one more time. You will understand it. Don't worry. Shall we try one more question with this case? Everyone, are you all paying attention? Everybody with me so far without any confusion, query, or concerns? So this part here tells us that, okay, how do we solve it? I say root x is actually x to the power 1 by 2. minus 4 can I write as minus 1? And there, if I divide it by x minus 1, I can write it like this. Plus root over root x, it is x to the power 1 by 2 to the power 1 by 2. So it is x to the power 1 by 4. This from 4, I take one more 1. And this x minus 1, I'll split here like this. Then this is root of x. So x to the power 1 by 2 to the power 1 by 2 to the power 1 by 2, which is 1 by 8. So this is x to the power 1 by 8 minus 1. Minus 1 means from 4 I'm snatching 1, and this gets divided by 1. Plus this is x to the power 1 by 16 by pattern which I have seen, and this again I write as x minus 1. Have you all understood what I'm intending to do here? X minus 1, x minus 1, x minus 1, x minus 1. That was the LCM. Good Ved, good Shubham, good Vijay, keep it up. And this 1, 1, 1 I took from 4, and powers I am keeping sorted. So this one I can write as 1 by 2, this one I can write as 1 by 4, this one I can write as power 1 by 8, and this one I can write as power 1 by 16. Does it match with something you already know? X to the power a, x to the power n minus a to the power n upon x minus a, x to the power n minus a to the power n upon x minus a, x to the power n minus a to the power n upon x minus a, x to the power n minus a to the power n upon x minus a. So what is the answer, sir? The answer is brilliant, brilliant, good Shilpa. Good Vijay, that's excellent. Good. Keep it up. Good Shubham. So here this part, n a to the power n minus 1. So n is 1 by 2. A is 1. So 1 raised to the power anything is simply that thing. So the answer from here will be 1 by 4. The answer from here will be 1 by 8. The answer from here will be 1 by 16. Everybody got it? I think you have the answer. You can simply say it is this 1 by 2 I can write as 8 by 16. 1 by 4 I can write as 4 by 16. 1 by 8 I can write as 16. 2 by 16. And this is 1 by 16. I hope I'm writing it correctly. Are you able to get it? Yes or no? 8 by 16. 4 by 16. 2 by 16. So 8, 4, 2, 1. Yes or no? 12, 12, 15, 16. So that's your 15 by 16. Everybody got it? So answer will be indeed 15 by 16, which you all have written. Shubham, Shilpa, everyone, Vijay, good. Keep it up. Really nice. Good. 15 by 16, if I write the approximate value, closest value, rounding off if I do, will be 0. As per our tool which we are using, I did not start a poll, so it will be 15 by 16, simple. No with Ved, what's going on? Why will it be 3 by 8? How do you simplify this? Can you really cancel 15 and 16? Do you really see something common? Now somebody in the beginning, I think it was Sandy, was very much concerned about Taylor series, Maclaurin series and all. So here we are with that expansion. Everyone, are you all paying attention? So few things I want you all to understand and remember is these. Sir, why? Why we really need to do this? Good, Harshika. That's brilliant. We really need to remember these because a lot of questions in ITJ Mains and Advanced are asked on arbitrary constants, where they say that this function and this function are continuous, where they say this function which has a piecewise definition is differentiable, and then they ask you the values of a, b, and c. Or sometimes they say that limit on this expression is something finite. And then they give you some arbitrary constants a, b, c in that expression, and they ask you the values of a, b, and c. So trust me, with L'Hopital or with some other methods, you may not be able to get the answer, but they are simply asking you to use series, Taylor series expansion, and with this you will get the answer very quickly. But sir, how? Yes, let's focus on that. So first of all, let's learn these expansions. First of all, whenever you talk about ln of 1 plus x, where x is between minus 1 and 1, I'll write it alternatively plus minus, where x square by 2, x cube by 3, x to the power 4 by 4, x to the power 5 by 5, and so on, with the plus minus sign alternatively. Will you remember that? Ln 1 minus x, I think, is very well understood by everyone. You simply substitute x by minus x, you get the result. This is something really crucial for all of us. This is what we'll be using at a lot of places, not only in mathematics, but I think a lot of places in physics as well. So I'll humbly request everyone to memorize it by all means. This is going to be a very crucial one. Please don't forget this. Similarly, e to the power minus x, you can, with some simple, direct, decent efforts. This one, a to the power x, it is actually a to the power x which we need to learn. And from here, if you substitute a by x, you get e to the power x. So a to the power x is 1, x into ln a, x square by 2 factorial into ln a square, x cube by 3 factorial into ln a cube, and so on. Sine, cos, and tan, how do I remember them? Sine I personally remember as odd function. So it will have odd powers alternatively plus minus and the same powers factorial in the denominator. Cos expansion I remember as even function. So powers will be even. The same powers factorial will be in the denominator and plus minus alternatively. But tan is something different. There you need to remember. At least these three terms you need to remember, you need to memorize, you need to by heart, you just cannot skip them. So these 4 expansions you are mandatorily supposed to learn along with these ones, e to the power x, log 1 plus x. So here, 10x has these 3 first coefficients you need to memorize. 10x, just like sine, is an odd function, but it is always positive, plus, 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 nothing alternatively plus, minus. But in this, first coefficient, x to the power 1 has 1, x cube has 1 by 3, x to the power 5 is 2 by 15. And you need to memorize it, you need to learn it. Shubham is saying, sir, in question, when this term comes, we should write its expansion till degree as a denominator to cancel just the amount. Yes, Shubham, yes. I'll show you, don't worry. The expansions of sec x, cosec x, cot x are really not very much needed, but I'll bring it in the next session, don't worry. Even the expansion of if you want sine inverse x, tan inverse x, all these inverse function also I'll bring them tomorrow or maybe in the next session, cos inverse x, if you really need it. But they are not very much needed, or rather I'll say very rarely they are needed. No trick, Shilpa. As I've told you, the kinds of observations which I've made, but for 10x there is no trick. There is no trick. So with this, if I move ahead, what do we see next? Few more standard limits. Based on them, direct questions are asked. So these are some limits which you will see as it is written in the question. So if you could strike that this is something which we are given in the question, I will humbly request, don't even solve, just substitute it 1 by 6. But sir, what if I don't want to remember? What if I cannot memorize a lot? What if I want to get the answer? How will I get the answer? So let me help you with the first one. This one, let's solve. This one, let's solve. So how do we solve this? Let's talk about it. Everyone, please pay attention. So what we know is expansion of sine x, limit x approaches 0. X is x. What is sine x? So sine x is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and some higher powers of x, which I write as big O. Big O. Big O means all the higher powers of x. I mean, you can write it as dot 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 as well if you're feeling confused with this dot dot dot. Whole divided by x cube. So here I hope everybody is noticing. Everybody is noticing x minus x is 0. But all the other terms become positive. So it becomes what? Plus x cube by 3 factorial, which is x cube by 6, plus x to the power 5 by 5 factorial, which is 120, and so on. And this x cube also divides it. This x cube also divides it, where limit x is approaching 0. So this becomes 1. This is a square. Few more higher powers I get. So ultimately I'll get 1 by 6 plus higher powers of x, which will be 0. So my answer is 1 by 6. Some of you may say, sir, why don't you use L'Hopital? Yes, you can. But a lot many times you won't be able to use it very, very easily. Rahul Gaming GMB 626 is asking, sir, I am new. I am from Kerala. I don't know from where to start. Please, sir, any suggestions how to start from scratch? Rahul, my friend, if you're genuinely or sincerely asking for this thing to be resolved, I am simply helping you with our beautiful channel where we have just released a lecture today. If you go to the videos section, there you'll find a video, how to cover backlogs in 6 months. Technically, its title is how to cover backlogs, but in this video, you will actually find the strategy to how to start from scratch if you really want to crack JEE in the January attempt. Same applies to Akhil Sidhu as well. If you're asking the same doubt, that sir, if I get sincere today, if I get serious today, if I genuinely wish to start my preparation, how can I genuinely start my preparation? If I start my preparation from today, here, just watch it. I have covered all the pointers, which I'm going to speak in this live. I've already covered them there. Just watch it with utmost focus, everyone. Coming back to the discussion we all were having, what was the discussion going on? So this is how these series expansions come into picture, and that's how you use them or utilize them. Everybody got it? Any queries or confusions you have, please ask. Shall I move ahead from here? So these are the ones which I'll ask you to memorize, which I'll ask you to remember. And if you can, it will be really beneficial for you. So x minus sin x upon x cube is 1 by 6. 10x minus x upon x cube is 1 by 3. X minus sin inverse x upon x cube is again minus 1 by 6. 10 inverse x minus x upon x cube is minus 1 by 3. So 1 by 6 minus 1 by 6, 1 by 3 minus 1 by 3. Sin x minus 10x. Sin x minus 10x upon x cube is minus 1 by 2. These 5 are some really straightforward ones, direct ones. If you could simply use them, you will get a lot of answers in a lot of questions. Good, Rahul. Glad to be some help. With this, I think these are few more ones. For example, if you want to work out this one, there are a lot of methods. 1 minus cos x. Okay, kindly highlight the correction, Abhishek Mishra. We'll really appreciate it if you genuinely tell us the correction. Saka 69 is saying, Sarji, I have been consistent from many months, but I'm scared I won't get a rank. Can you be more specific, Saka? Why are you scared? What exactly is the problem? And how do you define your consistency? And again, Saka, I'll request you to watch the same part where I have covered the part where you are putting your efforts, where you're pretending or assuming being busy with, being productive. You will get more clarity that how should you differentiate your fake preparation from your actual preparation. So even if you're consistent with the efforts in the wrong direction, why are you not getting a rank? Could be answered there in that video. So I'm requesting you to watch that video. Which video? As we have just discussed, students, I'll humbly request you to watch it if you are still confused how to cover backlogs. It's titled as how to cover backlogs, but a lot of questions will be answered of yours in this video. Shall I move ahead from here? So let's quickly take a break. Another 10 to 15 minutes break, and then we'll resume. Is that okay? We'll definitely have a word on that, Saka, but after a break. So we'll do a 10 to 15 minutes break, and then we'll resume. Is that okay, everyone? So if you all are still here, if you all can hear me, if you all are there, come back everyone. The break is over. I hope you must have hydrated yourself, walked around, stretched, and if you all can hear my voice, come back everyone. If you all can see me, if you all can hear my voice, come back everyone. Shall we resume? Shall we resume? Everyone, can you all see this? Again, a very good, a very insightful and a very good question. I'm starting a poll. Let's see how many of you are getting this answer. And then we'll see what is going to be the correct answer. Everyone, are you all set? Are you all ready? Can you all hear me? Can you all see my voice? Saka is saying, sir, I felt that there is too much competition. There is indeed, there is. You cannot deny it. And I felt that, too much time being wasted at school. We totally agree that if something not very productive is being done in those classes, you should try to do something really important, which is crucial or really crucial for you. So, the problem, Saka. And the best thing is if you have identified the problem, you will be able to solve it. So as I think Einstein has said it, I don't know exactly. Once you understand the problem, half of the problem is solved. I'll say your 90% is problem already solved, that you have already identified the problem. Just solve it. You know what's the problem. You can resolve it. You are intelligent enough to do it. Sopan, we start the class around at, it depends actually, it varies. So you just keep checking our live section. We keep it posted, so you'll be notified, don't worry. You can set the reminder as well so that you don't miss it. Duration Ved, I will be finishing it around 10 or 11, depending. If we are still, I'll not anyway, speed it up unnecessarily to finish it. So if we feel that this cannot be done in one session, I'll bring its part 2 in the next week. So this is how I'll keep it, Ved. Okay, so hello Ved, hello Vihan is going on. Hello Vihan, hello, hi, how are you? Ramesh, hi. So if that hello, hi has happened already, shall we now focus on our preparation? So this question here says e to the power sin x, 1 plus sin x upon 10 of sin x whole square. One very beautiful fact I wish to highlight here is, one very amazing fact I wish to highlight here is, before you solve this question, I want to show you 3 things. Which 3 things, sir? 3 things which I wish to show you are, give me a moment. I will show you, and that will help you in understanding a lot of things. First one is y is equal to sin x. First one is y is equal to sin x. Where did that x go? Sin x. Second one I want to show you is y is equal to x. And the third thing which I want to show you all is y is equal to 10x. Look at the beauty. It may look like a very beautiful design. Don't feel amazed by the design. I want to show you something really important, something really crucial. Everyone, please pay attention. This is the part which I want to show to you. This is the part which I want to show to you. I hope everybody is realizing this pink curve. This pink curve is the 10x. This blue or indigo you may call is sin x. And this orange one is your x. Now, why are we really discussing it? Let me take its screenshot and bring it there for you so that I can write a few things on it. So this is how I take the screenshot, and I think this is sufficient. Yes. So I'll save it. Give me a moment, everyone. I'll just do something really important here. So save, capture, and then I'll import it. So there we go. Before we solve this question, I want to bring something really important and crucial for you all. So let me just import this part. Where is that? Download pictures. Yes. So this is how we bring it. Everyone, are you all able to see it? Are you all able to see it? Yes or no? So what I'm trying to show you here is that blue one, this blue one. This blue one is sin x. This orange one is y is equals to x. And this pink one is y is equals to 10x. Now, sir, why are we discussing it? Have patience. I'll explain this. Why are we really discussing it? We are discussing it because when x approaches 0, from either left hand side or right hand side, look at them. If I even zoom it in, you will see when they get closer to 0, they all overlap. They all overlap, which means when x approaches 0, you will see, sin x and 10x to be same, right around 0. I hope you're getting it. You will see sin x and 10x to be same. So as x approaches 0, sin x, and 10 will be same. Mencia, you have asked a very beautiful question, and fortunately, I have answered it already twice, but for you, I'll answer it one more time. Here is a video for you. Just watch it. Crack JEE in 6 months. I think Mencia will do it. Coming back to the discussion. Everybody getting it? If you don't believe me, I'll show this to you by zooming it in. I hope at 0, if you just keep zooming it in, I hope you're seeing that it is absolutely overlapping. Are you seeing this? One of the students in our paid batches tells us that, sir, show us the atoms today. Your generation, its comments are always amazing. So he was saying that the more I zoomed in, he was saying that, sir, show us the atoms today. And what great comment it was. It was really nice, a very good comment, I really believe. So here I am saying that when you approach 0, sin x, and 10x are absolutely same. Vijay, forget approaching 0. I am saying that this pink one, which is looking like a pink, has blue one and orange one as well right below it. So I am saying they all are same. I hope you're realizing I'm talking about which curves, sin x, 10x, and x. When x approaches 0, either from left or right hand side, they all are same. So if they all are same, why are we really discussing it? We are discussing it because I'm trying to tell you something really amazing, that sin x, 10x, and x approach the same value when x approaches 0, which means if needed in the question, I wouldn't hesitate in substituting sin x by x if x approaches 0 or 10x by x if x approaches 0. Got my point? And that's exactly what I'm trying to do here. So here, if x approaches 0, e to the power sin x, can I write as e to the power? Of course, x is approaching 0, so let's keep it as x approaching 0. E to the power sin x, can I write as e to the power x? It doesn't create any problem. Getting it, everyone? Similarly, 1 plus sin x can be written as 1 plus x, or minus when pushed inside, it is minus 1 minus x. Because I'm clearly telling you that sin x, and 10x are absolutely same as x approaches 0. Understanding the logic? So what's the rationale behind it? This is the assertion. This is the logic. So with this, when I move further, I'm telling you that 10 of sin x is actually 10 of x whole square. Getting it, everyone? I repeat, sin x can be replaced by x. But sir, if you get 10x when x approaches 0 can be replaced by x. So this whole thing is actually x square. Everybody got it? Are you feeling cheated? Everyone understanding this? Everyone getting it? Now there are multiple ways. Sir, what multiple ways? One of the ways is that you use L'Hopital. You can. Other ways you use series expansion. So we are trying to learn series expansion. So I'll avoid doing L'Hopital and I'll do it with series expansion. But whichever way you wish to use, you can. Let me do it with L'Hopital first and then we'll use series expansion, everyone. Because it is 0 by 0, everyone noticing 1 minus 1, 0, 0, 0, yes or no? So if it is 0 by 0, I can use either L'Hopital or series expansion. So if I use L'Hopital, what does L'Hopital say? L'Hopital says differentiate numerator and denominator separately. So derivative of numerator e to the power x minus 1. Derivative of denominator is 2x. But sir, with L'Hopital, I think I'll have to apply L'Hopital one more time because when x approaches 0, it is again 0 by 0. Yes, yes, yes. It is best. Okay, it is not always best, trust me. Right now it may look best, but it will not always look best, especially in your examination JEE Mains. So if I again do L'Hopital e to the power x, and that's 2. So when x approaches 0, you have it as 1. So your answer will be 1 by 2. Beautiful, excellent. Now, what if I ask you to recall this expansion which we have just learned, e to the power x? Remember that? 1, I think, yes, 1 plus x, x square by 2 factorial and so on. Remember that e to the power x? So if I could ask you to apply that expansion, let's say we don't want to use L'Hopital, then how do we do it? So e to the power x, the expansion will be, e to the power x, the expansion will be 1 plus x, yes or no, plus x square by 2 factorial plus x cube by 3 factorial and so on. And then I have minus 1 minus x as well. So minus 1 minus x will get vanished. And there in the denominator, I have x square. And there I have limit x approaching 0. So x square cancelled, you're left with 1 by 2. All the higher terms have x. So it will become 0. So your answer will be 1 by 2. This was also easy if you noticed it. Good, 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 good. That's good. Ved, answer is not 6. Answer is 0. Good, Vijay. Answer is 0.5. I mean, yes, 1 by 2. Good, Harshika. That's good. I hope everybody realized and understood it without any hesitation or confusion. So, shall I move ahead from here? Did we start a poll? I think I did. So, 1 by 2, rounding off gives you 0. So, let's see how many of you got it 0. Answer is 1 by 2 indeed. Answer is absolutely 1 by 2. So, if you have written 1 by 2, you are absolutely right or correct. Shall we try one more question? Everyone. Mencia, my friend, as I have already told you, just watch it. You will get a lot of clarity. I have genuinely and honestly covered a lot of queries of yours. And this question which you're asking, that sir, is 99 percentile possible? I think you will get crystal clear clarity with that. You will get a genuine response or a feedback or a direct conversation between you and me through that video. Okay, Mencia. Good, good. It's core. Shilpa, that's brilliant. Keep it up. Really nice. Now, with this, let's try the next question. What does it say? It says limit x approaches 0, cos 4x plus a cos 2x plus b when x divides, x to the power 4 divides it, is finite. That's exactly the kinds of questions where I'll say L'Hopital is not very handy, and that's where expansion comes into picture. So they're asking you to find a and b and also find the limit. Amazing, amazing. That's brilliant. That's great. So if you know the expansion, you can crack it. How, sir? How? Kindly tell us. Okay, let's have a discussion on that. So how do we crack this question? Pay attention, everyone. Again, a very good idea will apply. I hope you do remember the expansion of cos x. Sir, I hope you do remember that for cos x, we learned that it is an even function. So for cos x, it is alternatively plus minus plus minus. Powers of x will be even, and that same powers factorial will divide it. Which means what? What do we get? What do we get? What do we get? I think we'll simply expand it. So the expansion looks like what? The expansion looks like cos 4x, cos 2x, and that's b. Cos 4x. So here I'll have 1 plus, no, it will be minus x by 1 factorial, but it is 4x. So it will be 4x by 1 factorial, which is 1. So I'll write it as 4x. The next term will be, I'm really sorry, powers will be even. So it will be 4x square by 2 factorial. So let me write it like this, 4x whole square by 2 factorial plus, now plus minus plus, powers are even 0, 2, 4. So next power will be 4x to the power 4 by 4 factorial and so on. Everybody got it? That's your cos 4x plus a cos 2x. So a times cos 2x will be simply replace or substitute this 4x by 2. So it will be 1 minus 2x by 2x square by 2 factorial plus 2x to the power 4 by 4 factorial and higher powers with what? With b. And this whole thing is getting divided by what? X to the power 4. Okay, sir. So that's your expression where x is approaching 0. And we are told that this limit is something finite. Good, Vijay. That's brilliant. Shilpa has already answered it. That's beautiful. Good, Shilpa. Kindly share your approach. How did you do it? We'll be really happy if you could tell us. And now what I do is I club a few similar looking terms. which means terms having power 0, constant terms if I club together. So I'll have 1, I'll have A, and I'll have B. So that's the constant term. Then I'll club the terms with the power x as 1. So power of x as 1, I don't have. So x square terms I'll keep together. So terms which are having x square, if I keep together, this is 16 by 2, which is 8. So it is minus 8x square. So if I take x square outside, I'll have minus 8. Getting it, everyone? Then here, this will be 4 by 2, which is 2. So this is minus 2ax square. So this is minus 2a. Everybody getting it? Then the terms with x to the power 4. So terms with x to the power 4 are going to be what? X to the power 4. This is 4 by 4 factorial. 4 by 4 factorial. 4, 3, 2. Yes or no? 4 and 4 are cancelled. So 3 into 2 is 6. So I'll get 1 by 6 from here. Everybody processing it. From here, what I'll get here is 4 factorial. Again, 4, 3, 2. And that's 2. So this 2 when divides it, 4 into 3, that's 12. So 1 by 12, but a by 12. So this will be a by 12. And I will get higher powers of x, which are x to the power 6 and so on. Plus, minus, whatever I get, I don't care. But I'll get higher powers of x. And this whole expression is divided by x to the power 4. This whole expression is divided by x to the power 4. This whole expression is divided by x to the power 4. Limit x approaches 0. Now you tell me, by using your own intelligence, what do you think? Sir, it has higher powers of x, x to the power 4, x to the power 6, x to the power 8, and so on. Okay. And we are told that it has a limit which is something finite. Which means, sir, if I put x as 0, constant, plus 0, plus 0, plus 0. So numerator is constant plus 0. Denominator is 0. So constant upon 0 is infinity. So according to us, this is approaching infinity. Come on, sir. We are told it is finite. But according to your calculation, it is turning out to be infinity. That means there is some problem. What's the problem? The problem is, sir, if I could get rid of these few terms. Which few terms? Imagine this for a while. Let's say this term is not here. Let's say this term is not here. Let's say these two terms are not here. Then what will happen? Sir, what may happen is x to the power 4, x to the power 4 will get cancelled. X to the power 6 will become x square. Next will be x to the power 4 and so on. And because of that, we would notice that, sir, all the higher power terms with x will vanish because x is 0. Here, x to the power 4, x to the power 4 are cancelled. And I am getting something finite as my answer. I'm getting something finite as my answer. So this beautiful thing would have happened. But when would this beautiful thing happen? This beautiful thing will happen if I get few things done. Which few things? First of all, sir, ensure that 1 plus a plus b becomes 0. Okay. Let me ensure 1 plus a plus b becomes 0. Sir, ensure that minus 8 minus 2a becomes 0. Okay, I will ensure minus 8 minus 2a becomes 0. So what happens when you do that? 2a is minus 8. So a gives you minus 4. So here you get a as minus 4. That's your first conclusion. I think we have gotten the value of a, which some of you have also gotten. That's good. That's good, students. Similarly, if I push a as minus 4, this is minus 3. So b we receive as 3. So from here, b we get as 3. Okay, sir. So we have gotten b and a both. That's the first part. Now, once you do it, I hope you do realize. Once you do it, I hope you do accept and realize what is going to happen now is, sir, you have ensured that 1 plus a plus b becomes 0. That means this will vanish. You have ensured minus a minus 2a becomes 0. That means 0 into x square will vanish. So this is what? 0 plus 0. Then here I hope you are noticing this will totally vanish actually. And then what I'll have is x to the power 4 by x to the power 4. So this will totally vanish. And then with the remaining terms, I'll be left with higher powers of x. I'll be left with higher powers of x. And if I'm left with higher powers of x, and if x approaches 0, they all will vanish. So technically, I'll be left with this as my final answer. This is my answer. But sir, can we really call it an answer? No. I need this a to be substituted. So I'll finally say that my answer will be 1 by 6. A is minus 4. So it is minus 4 by 12. If I write it as 2 by 12, can I write 1 by 6 as 2 by 12? So it is minus 2 by 12, which is minus 1 by 6. And that's your answer. That's your limit. So I think we have A, we have B, we have limit. So minus 4, 3 and minus 1 by 6. Minus 4, 3 and minus 1 by 6. That's, Shilpa, I think the only thing which you got wrong was, I think the limit. Limit should be minus 1 by 6. Shall I correct it? I think other things are great, going great, finite, brilliant. Absolutely. Coefficient wrong. Are you sure, Vijay? Did I make any mistake? What mistake did I do? Let me just cross check it again. This is what we are supposed to do. So 1 minus this, then plus this, power 2, power 4 and so on, power 2, power 4 and so on. This is 4x, this is 2x. So 4x square by 2 factorial. Will it be 16 by 2? 16 by 2 is 8. So I think I wrote 8. And this will be, oh, yes, I made a mistake. How can I do this? Such a silly mistake. I forgot 4. Yes, I made a mistake. I'm really sorry. I did not notice it. Apologies. Sincerest apologies. Nobody told me while I was doing it. Come on, you're watching it sincerely, aren't you? I'll have to do it again. I mean, one thing I'll do here is, numerator will have 4 cube upon what? 3 into 2. 6. Yes or no? 4 cube upon 6. 4 cube is what? 64. 64 upon 6. That is 32 upon 3. So this will be 32 upon 3 actually. Nobody told me. Come on, that's unbelievable. So where will I write it? 32 upon 3 x to the power 4. So this will be 32 upon 3. This will be 32 upon 3. This will be 32 upon 3. And what will happen here? I think I made the same mistake here as well. I think this was 4 by 2, which is 2. So it was, I think, correct. Yes or no? That part is sorted. Then there, 2 to the power 4 by 4 factorial. Okay, again. So 2 to the power 4 is 16 by 4 factorial, which is 432. So that's 8 into 3. 8 and 2 is, so that's 2 by 3. Yes or no? So that's 2 by 3. I'm really sorry. So that should be 2a by 3. So if I do so, my answer should be 32 plus 2a by 3. My answer should be 32 plus 2a by 3. Correct me if I'm wrong. I hope this time it is not going wrong. Yes or no? Yes or no? Yes or no? Everybody getting it without getting confused? So if I push a as minus 4, what do I get is minus 4 into 2. Minus 4 into 2, that's minus 12. So 32 minus 12 by 3. How much is that? That's 20. Yes or no? 20 by 3 should have been the answer. I hope it's correct now. By the time I was solving this question, I got a lot of. Okay, thank you so much, Vijay. I think I might have missed. Akash is saying how to cover backlogs of Laksh in English. Akash is saying how to cover backlogs of Laksh in English. Okay, Akash, I got your query. Akash, for you, we have brought something really interesting. Luckily or coincidentally today only, you just visit our YouTube channel, PWJ English, where you're watching this live. And in the video section, you'll see a video which, in a very comprehensive manner, covers, handles, and resolves your query. Why is it 8? I think the answer will be what? 20 by 3. I think it's correct now, isn't it? Are you still making any mistakes? Is it not resolved now? I think it's correct now. Did I really make any mistakes? 64 by 4. I mean 64 by what? I think we are going great. Whatever calculation mistake I'm doing, let me do it again. 4 to the power 4 by 4 into 3 into 2. So it is 4 cube. 4 cube is what? 4 cube is 64 by 3 into 2. 3 into 2 is what? 3 into 2. So that's 32 by 3. So that's 32 by 3. I hope I wrote 32 by 3. Yes, I wrote 32 by 3. The next thing was what? 2 to the power 4. 2 to the power 4 is what? 16 by 4 factorial, which is 4, 3, 2. So that's 8 into 2. So 2 by 3. So that I wrote as 2a by 3. So it's correct, students. It's correct now. Don't have to worry. It's correct now, everyone. Yes, I told you that the value of a here is minus 4, b is 3, and based on that, you can work it out. If I'm making any mistake, correct me in the comments. It's correct, right? It's correct. You do it by yourself if I'm making any mistake. Shall I move ahead from here? Now, as I have just told you or have shown you this part where I have tried showing this to you that sin x, tan x, and x are absolutely same. when x approaches 0. I hope you can notice it. They completely and totally overlap. I hope there is no difference. The more I zoom it in, the more clarity I get. Yes or no? So what I'm trying to highlight or make you understand here is very direct, straightforward fact. This is that if sin x and x are same, a I did not take as -4. Come on, I took a as -4. Okay, yes. I think I made a mistake. A if taken as -4 into 2. Yes. Thank you so much, Shilpa. You're so consistent with your demands. Good. Keep it up. So this is 32 minus what? Plus 2a by 3. So a is -4. -4 into 2 is what? -8. So that's 3. 32 minus 8 is what? 24. And that's 8. Good. Keep it up. Really, Shilpa. That's how you win. You stick to what you want. Your generation. Good. Keep it up. Really nice. Very good. So now I'm explaining one very interesting fact, that remember this as a direct limit. And whenever you see something like this, you just directly apply it. What am I suggesting here is pay attention, everyone. Let's say I am told sin x upon x. So if I know that this and this, they approach 0, then this will approach 1. If x approaches a minus a minus a. So if they are same and approach 0, this whole thing will approach 1. Same applies to 10. 10x upon x is 1. 10x minus a upon x minus a when x approaches a is 1. Sin inverse x upon x is 1 when x approaches 0. 10 inverse x upon x when x approaches 0 is 1. Similarly, sin of anything upon that same thing will be 1 if that thing when x approaches a is 0. Getting my point? No, Janvi, don't be foolish in doing this. I understand that you have this feeling that 11th is wasted, but trust me, you really don't have to spoil another year. When you get this break between 11th and 12th, you can cover it there. Trust me. There are ways to cover it. We'll address it someday, but you can, Janvi. You just need to work it out. Watch the video which I have just told you. If somebody has wasted whole 11, there is a scope, there is a chance, and which I have covered there. We'll cover that complete revision. We'll cover all the classes, all the subjects of 12th, and we'll cover all the classes, all the subjects of 11th as well. I mean, all the chapters of 11th and 12th, both before your January attempt. You have my assurance, everyone. So if you have understood these limits, let's focus on a question which will give you a complete crystal clear clarity on this concept. Everyone, are you all there? Listening, watching, and understanding. So here, what does it say? Evaluate x approaches pi by 2, 1 plus cos 2x upon x minus 2x whole square. Okay, what are the ways? I think the simplest idea to be applied here is, can you help me with this formula? 1 plus cos 2 theta. What is that? So that is 2 cos square theta, which is x. Yes or no? Yes or no? Everybody understanding it without any confusion? Yes or no? Had it been 1 minus cos 2x, I would have written as 2 sine square x. But it is 1 plus cos 2x, it is 2 cos square x. And the denominator has pi minus 2x whole square. Any confusion so far? Any queries so far? Are we clear on that, everybody? Now the next thing which I suggest you to do is cos square x. Can I write it as 1 minus sine square x? Do we really need to? Or x is approaching technically pi by 2. I hope this question is correct. So there you have limit x is approaching pi by 2. By the way, when I push pi by 2, what do I get? I get cos pi, which is -1. So 1 minus 1 is 0. Pi minus pi, which is 0. So 0 by 0 form. So you could have used L'Hopital directly here and gotten the answer. But if I do this, 2 cos square x upon pi minus 2x square, what will I do here? Shall I write x as something or convert it into sine? Or shall I split it into something? Can I use L'Hopital directly without using any standard limit? Because I don't think that there is any point of, I mean, what's the method I am stuck in? Anyways, shall we use L'Hopital instead of thinking much? Everyone, are you all set? Everyone ready? So there I'm suggesting that if I use L'Hopital, because it is a 0 by 0 form, L'Hopital can be used. Derivative of 1 will be 0. So limit x approaches pi by 2. cos 2x will be minus sine 2x, and derivative of 2x will be 2. Yes or no? Denominator, I have pi minus 2x whole square. Chain rule says 2 times pi minus 2x. Derivative of pi minus 2x is minus 2, which is written over here. Everybody got it. I hope no confusion. So now if I simplify this, what do I get as a result? Limit x approaches pi by 2. In the numerator, this minus 2 are cancelled. So you have sine of 2x whole gets divided by 2 times pi minus 2x. So if I do it one more time, if I apply pi by 2, so this is pi by 2, sine pi is 0, pi by 2 if I push, it is again pi minus pi, which is 0. So if I apply L'Hopital one more time, sine 2x will be 2 cos 2x. This will be 2 as it is. Derivative of pi minus 2x will be minus 2. So this will be minus 2. So again the same limit, x approaches pi by 2. 2 and 2 are cancelled. Cos pi is minus 1. This is minus 2. Minus 1 by minus 2 is 1 by 2. Everybody understood it. Do you have any other approach? Any other queries? When will you start continuity? Krishiv is asking. When we are done with limits, Krishiv? Very soon. I mean, we are on the verge of completing limits, and very soon we are going to start continuity as well. Yes, Shilpa, we can and we have used. But if there is any other approach, you should tell me. Vijay, answer is not 0, it is 1 by 2. Here comes another question. Let's solve this one. Everyone, are you all paying attention? Here, x is approaching 2 on this expression. Okay, sir, how do we solve it? Here I say that numerator minus 2 plus x, and here if I take x common, okay, or rather, okay, that I'll do here. So, one thing I'm suggesting here, please pay attention everyone, limit x approaches 2. Numerator x square minus x plus 2. I mean, if I substitute 2 here, I think you're noticing 0. This is 0, this is 0. So 0 by 0 form. L'Hopital you can directly use and get the answer. But let's say you don't want to use L'Hopital. What else you can do is x square minus 2x plus x minus 2 in the numerator. This thing over here, if I take x common, I'll be left with x minus 2 minus sine x minus 2. Everybody got it? Yes. So numerator has x minus 2, but x and plus 1. So x minus 2, x plus 1, right? So what I'm thinking of doing is, let's divide numerator and denominator both by x minus 2. If I divide numerator and denominator both by x minus 2, what I get is limit x is approaching 2. Numerator will be left with x plus 1. Denominator will leave me with x here. And this will be sine x minus 2 by x minus 2. Everybody got it? Yes or no? All the participants. Now, when x approaches 2, this will be 2 plus 1, which is 3. When x approaches 2, it's clearly 2. And when x approaches 2, sine 0 by 0, that's 1. Correct me if I'm wrong. Yes or no? So this will be 3 by 2 minus 1, which is 3. That's your answer. How many of you got it as 3? Vikram, I'll try to, but the class will be stretched as we are doing this whole chapter, limits, continuity and differentiability, in one shot. It will take some time, but if at any moment I feel that it is getting stretched and you are not comprehending, then we'll stop it there. We'll divide into 2 parts and then we'll do the remaining things in the next session. Happy? Good. That's brilliant, students. Answer is 3. Vikram, thank you so much, but let's mind our language. Sky Gazer, no problem. This is a channel where we keep it in pure English. I hope you got my point. Don't worry, Sky Gazer. I mean, if you can understand English, I get it. I get your concern, Sky Gazer, but we keep it in pure English. We keep it in full-fledged English. And Vikram Raj, let's take care of our language. I get your point, but let's be more respectful. Yes or no? That's a better language, Vikram Raj. Good, keep it up. So I hope you all got it. Everybody understood it. Shall I move ahead from here? All the participants. Here comes another very beautiful, very insightful, and a very good question. See, they have put a condition here. So what's the problem? As I have been telling you that you don't have to bother about LHL and RHL, but sometimes you need to consider it specifically when you're doing with GIF, fraction part, modulus, signum. There you need to be more careful with LHL and RHL. Look at this question. Sir, why are you bringing LHL and RHL? Here. Limit x approaches 0. That's x approaches 0. But denominator has x. Numerator has half. Half is half. I don't. But 1 minus cos 2x is 2 sine square x by 2. So that's 2 sine square x, because it is 2x. It will be x. And this 2 and this 2 are getting cancelled. So you're having this 2 over here. But you are having an under root sign over here. Now, some of you may say that, sir, under root and square are cancelled. And your answer is sin x upon x, which is 1. How many of you think that answer will be 1? Do tell me. How many of you think that answer will be 1? Let me know. I've started a poll. How many of you know or believe that answer will be 1? I hope some of you are aware of this fact that under root over x square is not x. It is actually mod x. It's a mathematical error which some of us commit while solving questions. So it's advised that you do this instead of this. So here also that same thing needs to be taken care of, that x is approaching 0, so sin x could be either positive or negative. So I need to be careful that I simply put a mod so that when it comes out of under root sign, it stays non-negative. Absolutely, Vijay. Very good observation. So there, I'll put a mod over here. So it will be mod of sin x upon x, where x is approaching 0. And again, as we all very clearly know, that sir, if x approaches 0 from positive side, sin x is positive, between on the just right side of 0. Just on the left of 0, sin x is negative. So I'll be doing LHN and RHN. So limit x approaches 0 from left hand side, mod of sin x will be minus sin x upon x. Sin x upon x is 1. So it will be minus 1. But when I talk about RHL, it will be limit x approaches 0 from right hand side, mod of sin x. Sin x is positive. So mod of sin x will be sin x upon x, and it will be 1. So LHL and RHL both exist, but they are not same because they are minus 1 and 1, and that's why it does not exist. Everybody got it? So if you were believing that the answer was, if you were thinking that the answer was, why are we having this? Poll should be stopped. Correct the correct option. Correct option is not there, so I'll just select anything. But let's see how many of you got it wrong. With Ved, did you get it? Answer is not 1. Did you realize the mistake? With Ved is not responding much in comments. Okay, he told plus minus 1. Yes, the answer will be does not exist. Good. Keep it up. Good, Shilpa. That's good, Vijay. Brilliant. That's really nice. With this, shall we move towards the next question, everyone? Are you all there? Listening and understanding? Again, a very good, insightful, and a decent direct question. If you could think of it, you can crack it. Here we are. What does it say? It says that limit x approaches 0, sin pi cos square x upon x square. Okay, sir, what do we do here? If x approaches 0, cos 0 is 1, sin pi is 0. This is 0, so 0 by 0. So L'Hopital shall we use? You can. But if I apply, what I am thinking of doing is, can I do this? Sin of pi cos square x whole. Shall I do this or do that? I'll do that. Okay, here. Sin of pi is pi. Cos square x by an identity, I hope I can write as 1 minus sin square x, and you're not offended by that, aren't you? I hope you are not. And I have x square in the denominator. Everyone comfortable with this thought? Sir, why have you really done it? Okay. Imagine this, that it is limit x approaches 0, where you have sin. Pi gets multiplied inside, so it is pi minus pi times sin square x. Whole gets divided by x square. Correct me if I'm wrong. Now you tell me, what is sin pi minus theta, students? What is sin pi minus theta? So second quadrant, pi keeps sin, and second quadrant, sin stays positive. So it is sin theta. Same logic if I apply here in this part. Sin pi minus theta, that's sin theta. So I'll write it as limit x approaches 0. Sin theta, what is theta? This is theta, which is pi of sin square x. And this whole thing gets divided by x square. Everybody with me so far, is there any confusion? Are you all there? Now, one thing you all can do is, as we have just learned, that if x approaches 0, sin x can be replaced by x. So if you want, you can write it as x square. You can write it as x square. Remember that we have learned it. Yes or no? So here, this is x square, this is pi x square. So sir, you need a pi here. I hope you do remember. So now, sin pi x square by pi x square when x approaches 0 is 1. So your answer is going to be pi. How many of you got it? How many of you understood it? How many of you were able to crack it? Everyone, are you all there? Listening, understanding, and getting it without any confusion, without any queries, without any concerns? Everybody got it? Or shall I re-explain this part? All the participants. Shall we move ahead from here? Now, this is a very good, very beautiful, very interesting question. Let me remove this proof. Actually, it is wrong. I have deliberately kept it. First of all, tell me what should be the answer to this question. And I'll bring one more question where I'll change it slightly. Change it slightly means that here I'll do a slight change, that instead of putting this GIF sign over here like this, I'll put this GIF here. So two questions I'm giving you. In one question, there is limit inside GIF. In second question, there is limit outside the GIF. Help me with this. What do you think? First of all, is there any difference? There is a debate going on among the fraternity of mathematicians. I was in that group. All the teachers of JEE Mathematics were there in that group, and they were debating over this thing, that what should be the answer when limit is outside of GIF, when limit is inside the GIF. Whatever or wherever it is, first of all, let us notice sin x upon x. Now, some of you may think that sin x upon x is anyways 1. So GIF of 1 is 1. So answer should be 1. So why are you putting it equal to 0? That's a bad practice, sir. You are doing it incorrectly. You are doing it incorrectly. That's wrong, sir. Why are you putting it 0? That's wrong. Similarly here also, why are you putting it equal to 0? That's wrong, sir. That's wrong. Okay, so I accept you're wrong, but why? Can you explain both of these things? Can you first of all explain, are they same? Absolutely, Vijay. Can you explain why? Absolutely, Vijay. That's a very good observation. And I'm sure some of you may have noticed it. Actually, when you talk about sin x and tan x, let me help you with this thing over here. Please pay attention. Sin x upon x approaches 1 from left hand side, which means actually sin x upon x in terms of limits is indeed 1. When I'm talking about this, when x approaches 0, sin x upon x is 1, I mean in terms of limit, but it's very close to 0.9999, something like that. Whereas tan x upon x also approaches 1 when x approaches 0, but from right hand side, which means tan x upon x when x approaches 0, I mean I'm talking about the values, very close values to 0, is actually very close to 1, but from the right hand side. It's like that. Are you understanding the hint I'm trying to give you here? Absolutely, Vijay. Keep it up, really nice. All the other students who are watching it sincerely, have you gotten it? Have you all understood it? So here in this case, imagine this. Sin x upon x, first of all, what will I apply? The GIF or the limit? Sir, in this case, you will apply the limit first. Yes or no? You will apply the limit first. Yes or no? So if you apply the limit first, sin x upon x, when limit is applied, you got 1. So GIF of 1 is 1, and that's your answer in this case. Because sin x upon x, when limit is applied, it is 1. So that's your answer. Everyone getting it? But here in this case, sir, wait a second. Limit will be applied, x approaching 0 on sin x upon x, but its GIF you'll take first. Limits perspective you do here, but on what? GIF of sin x upon x. Sir, what does it mean? Absolutely, Vijay. Very good. Keep it up. So in this case, sin x upon x is yes 1, but it approaches 1 from the left hand side. So technically the number which you are seeing in the GIF sign is something very close to 1, but from the left hand side, and in that case answer will be 0. So are you noticing and realizing the difference between both of the things? When it is outside, it is 0. When it is inside, it is 1. Everybody got it. Everybody understood it. Shall I bring few more cases now? Let's talk about exponential and logarithmic limits. I hope so far whatever we have done is very well, very easily and directly understood by everyone. No confusion. All the participants understanding all of this comfortably, directly and clearly. Next part when I bring into picture is this, that first of all understand this thing, that e to the power x minus 1 upon x will be 1 if x approaches 0. Which means if I ever see e to the power something minus 1 upon that same thing, when x approaches a, let's say f of x approaches 0, so I'll not hesitate in substituting it by 1. Only when f approaches 0. Everybody getting it? E raised to the power anything minus 1 upon that anything, when approaches 0, it approaches 1. Is my language understandable? Extension of this part, have you all gotten it? Same extension of this part can be brought here. Ln of 1 plus something upon that same thing will also be 1 if x approaches a and f of a approaches 0. Same logic can be applied here as well. A to the power x minus 1 upon x is ln a if x approaches 0. Will you all remember all these three limits and their extended versions? All the participants getting it or not? Everyone. So if you have gotten it, let's see a few more cases, which I have already explained to you. Now let's solve few more questions. Everybody with me so far? Any queries or concerns if you have, please ask. Everybody. Shall we do this question now? What does it say? It says that here, just give me a moment everyone. Vijay है क्या? विजय चाय पियोगे क्या? चाय पियोगे? शक्कर मत डालना. Okay, so with the basis on whatever we have learned so far, try solving this question, everyone. All the participants, try to solve this, everyone. So, how do we solve this? Shall we talk about this, everyone? Limit x approaches to x minus 2, x minus 1. So, if x approaches to 2 minus 2, 0, 2 minus 1, 1. So, it is clearly 0 by 0. The best thing is L'Hopital. The best thing is L'Hopital. But sir, in this question, L'Hopital is okay. But if you want to learn what we are trying to learn through this standard rule, which we have just explored, these cases, everyone, remember them? What if we want to learn these? You can, but right now it's advised that you apply L'Hopital because it is 0 by 0. Yes or no? So with 0 by 0, yes, hello, hi, namaskar, everyone. All who are eager to say namaskar, yes, yes, yes. As long as we are studying, I think limits will be trying to cover. So it may last till 11. Continuity and differentiability I will do tomorrow, I mean in the next class. But today we'll cover limits. Cinematic Eagle and Shri Joy Meti, right? So good, Subhash, that's brilliant. Let's see what is the answer. So I think L'Hopital, because 0 by 0, x minus 2's derivative is 1. Log, try and understand the base is a. It's not having the base e. The base is a. Pay attention, everyone. That's the catch. So ln of x minus 1 has a derivative 1 upon x minus 1, but it has a base a. So what you'll do is you'll multiply it by log a. I hope you remember it. If you don't get it, let me explain it here. Everybody, let's say I write it as log x minus 1 at base a. Yes or no? So by change of base formula, can I not write it as log x minus 1 at base e upon log a at base e? That's what I was talking about. Everyone getting it? So here the question gets rewritten as x minus 2. That's derivative is 1. So derivative of numerator is 1. Derivative of denominator. So denominator is actually this. Log of x minus 1 at base e. The derivative is 1 upon x minus 1. Getting it, everyone? Yes or no? And derivative of x minus 1 as per chain rule is 1. And this being scalar stays there. So it is 1 upon log a base e, which I can write here in the numerator, 1 upon log. Everyone processing it, understanding it without getting confused, all the participants, yes or no? Or if you're not getting it, I'll write it here so that you don't feel confused. This here as 1 upon what? Log a base e. So that is log a base e. Everyone getting it? Yes or no? All the participants. Now what we do is we take it there in the numerator, but limit x approaches 2 is also what we apply. The division, the proper division was this. I hope you do remember it. So there we apply limit x approaches 2. So this whole thing goes to the numerator. 2 minus 1 is 1. So ln a is your answer. So if you're saying that answer is what? Yes, answer which is not 1. That's good, Shubhash. Answer would be ln a. Beautiful, beautiful, beautiful. Excellent. Keep it up. Really nice. Shall I move ahead from here? Did you all get that part? This one. How do we solve this? Again, the best practice will be L'Hopital. I think you're done with this question because if you're using L'Hopital, log a, so 0 minus 0, that's 0 by 0. So here you get what? Log x derivative is 1 by x. X derivative is what? 1. So limit x approaches a, the answer will be 1 by a. Direct. Nothing needs to be done in this question. Here, I'll say that in this question, what I'll do is log of 5 plus x upon x minus, or shall I do it directly with that logic? Shall I apply L'Hopital? Sir, why L'Hopital? Because when approaches 0, log 5, 0, 0 by 0. So log 5 plus x will be 1 by 5 plus x. 1 by 5 plus x. This will be minus 1 by 5 minus x. Everyone getting it? And this will be 1. And their limit x approaches 0. So if x approaches 0, this is 0, this is 0, 1 by 5, 1 by 5, 0 by 1, that's 0. I think that's easy, doable. Everyone getting it? Any confusion? Okay, so there comes the most interesting limit, which is this, that if you ever get, what a beautiful expression they have given. Good. So if you ever get 1 plus x to the power 1 by x, where x is approaching 0. So if this is very small, this will be very great. So 1 plus very small raised to the power very great will be actually e. Opposite, if x is approaching infinity, so 1 by x is very small, 1 by x is very small, x is very big, that is again e. So Napier's constant is actually given by this. Same Napier's constant is extended into this result as well. If you ever see x is approaching a, 1 plus fx to the power 1 by fx, if this fx approaches 0, then 1 by fx will approach infinity. So 1 plus 0 to the power infinity is e. Getting my point? Getting my language? Or are you able to digest it? Yes or no? Everyone processing it? Everyone will remember it? And if you will, let's solve a question and get more clarity. What does it say here? Let's solve it. Everyone, are you all paying attention? This part over here says, find the following limits. Limit x approaches 0, 1 minus x to the power 1 by. I think that's easy, that's doable. What I'll say here is that what if I do this? What if I do this? Limit x approaches 0. I'll write it as 1 plus minus x, yes or no, whole raised to the power 1 by x. So 1 by x, if I write as 1 by minus x whole raised to the power minus 1. Why? Because minus 1 minus x are 1 by x. This is sorted. So if this part approaches 0, this part approaches infinity. So 1 plus 0 to the power infinity is e. So answer is e to the power minus 1. If you didn't get this approach, I'll do it slightly differently. What could that approach be? That approach has everything to do with 1 to the power infinity form. What is 1 to the power infinity form? If x approaches 0, this is 0, this is 0. So this whole thing will be infinity. So I hope you're realizing 1 minus 0 is 1. 1 by 0 is infinity. So this is clearly 1 to the power infinity form. Now for a 1 to the power infinity form, you would learn a short trick. What is that short trick? Let's talk about that. The short trick is, if base is approaching 1, power is approaching infinity, then the answer is given by e to the power base, which is 1 minus x minus 1 times the power. And the same limit gets applied. Everyone heard what did I say? What did I say? I said, if base is approaching 1, power is approaching infinity, then your answer is given by same limit e to the power base minus 1 into the power. Did you all get it? With this, what I'll say here is that 1 and 1 are cancelled. Minus x upon x is minus 1. So answer will be e to the power minus 1. Everybody got it? Based on that, can you not try the next two questions? Shall we, everyone? Let's focus on the next question in that case. What do we get? Shall I now start applying this formula directly, all the participants? Here in this case, when x approaches 1, log x approaches 0. When x approaches 1, log x approaches 0. So this whole thing approaches infinity. So this whole thing approaches 1. So it is again what? 1 to the power infinity form. I hope I'm not confusing anyone. You are able to process this whole idea, yes or no? So whenever you get 1 to the power infinity form, what's the answer? The answer is e to the power, this base minus 1. So 1 plus ln x minus 1 is ln x. Yes or no? The same limit x approaches 0. And this power should be multiplied with this power, which is 1 upon ln x. So this and this are cancelled. You're left with e, which is your answer. And that's exactly what I've told you. If this is 0 and this is infinity, then it approaches e. That's exactly what we have discussed, haven't we? Let's apply that same idea here. When x approaches 0, sin x approaches 0, so this whole thing approaches 1. When x approaches 0, 1 by x approaches infinity. So this is again what? 1 to the power infinity form. And for 1 to the power infinity form, what's the short trick? Good to have you, Tushar. Let's study. If you are sincerely want to study, good to have you, Tushar. Amazing, really nice. Good, Vijay, that's brilliant. So for this part, what I'll do is, again, the answer is limit x is approaching 0, e to the power, this base minus 1, so 1 plus sin x minus 1 is sin x, into the power, which is 1 by x. If x approaches 0, sin x by x is 1, so my answer will be again e. I hope this was easy, understandable, it makes complete sense. With this, can you try solving this question, all the participants, if you have understood the properties? Good, Shubhash, that's brilliant. Absolutely, absolutely, true, brilliant, keep it up, really nice. This question here says, if x approaches 0, this is told to be e cube. This is told to be e cube. Okay, so when x approaches 0, this limit is told to be e cube. Okay, so how do we solve this? Okay. So if x approaches 0, this will be 0, this will be 0. So it is 1 to the power infinity. Yes or no? I hope you're realizing it. Shall I highlight it again? I am saying x approaches 0. So this became 0, this became 0. So this whole base became 1. This became 0. So 2 by x became infinity. So it is clearly 1 to the power infinity form. Everyone can imagine this in brain. Sir, for 1 to the power infinity form, answer is limit x approaches 0, e to the power, this base minus 1. So this base minus 1 means what? Ax plus bx squared. 1 and 1 are cancelled. Multiplied with this power, which is 2 by x. So 2 stays outside, x stays there. With this, what do I get? Sir, we get x and x are cancelled. So e to the power, I get 2a plus bx, where x is approaching 0. So if x is approaching 0, this is 0. So my answer is e to the power 2a. Their answer is e cube. Base are same. 2a will be 3. So a will be 3 by 2. Everybody understood it. So I think, sir, what about the b? What could be the value of b? I think it is independent of b. b can be anything. Yes or no? I have no problem in b or with b. So b can be any real number, but a has to be 3 by 2. Everybody got it? That's the formula which I have been using constantly. So I'll just put it there before all of this so that when you revise the notes, you get it completely and totally. This is the formula which we have been using. I hope you won't forget it anymore. Let's solve one more question. Again, a very beautiful one. Here again. What I'm saying is when x approaches 0, a to the power 0 is 1, b to the power 0 is 1, c to the power 0 is 1. 1 plus 1 plus 1 is 3. 3 by 3 is 1. And this is 0. So this is infinity. So I hope everybody has clearly noticed that it is again 1 to the power infinity form, isn't it? Everybody realizing it. That's good. Vijay, Shubhash, everyone, all the sincere aspirants. How do we solve it further? So to solve it further, what I'll do is, it is 1 to the power infinity. Idea is e to the power. The same limit I'll apply. X approaches 0. This power, a to the power x plus b to the power x plus c to the power x whole divided by 3 minus 1 multiplied by the power, which is 2 by x. Everybody got it without any confusion? Good, good, Tanishq Jadhav. Good to have you. Amazing, nice, really nice. Keep it up. Then what I'll do is 3, I hope can be pushed there as -3. So this will be -3 by 3. This -3 can I write as a to the power x minus 1 plus b to the power x minus 1 plus c to the power x minus 1. This 3 can be splitted. This 2 and 3 I'm keeping outside, and this x I'm pushing here. So x I'm writing here, x I'm writing here, x I'm writing here. So what I've done is x I have written like this. And this whole thing I'm raising as the power of e with the 2 by 3 outside, where x is approaching 0. Now, do you remember something really simple, direct and straightforward we have discussed when we started discussing it, the first formula? This one. A to the power x minus 1 when x approaches 0 is ln a. Remember that? That same logic I'll apply here. So ln a finally takes you here. So a to the power x minus 1 by x when x approaches 0 will be ln a. So this will be e to the power 2 by 3 times ln a. This will be ln b. This will be ln c. So log m plus n is log mn. So e to the power 2 by 3 ln abc. Yes or no? I hope you do understand this 2 by 3 can be raised as a power of abc. It will be e to the power ln abc to the power 2 by 3. So this ln and this e have the same base. Ln means log base e. This is e. So if this e and log's base is same, answer is this. So it will be abc to the power 2 by 3. Everybody got it. Everybody understood it. Simple, easy, direct, straightforward question it was. Nothing new I have done. You knew all these things directly and clearly. Weren't you aware of it? You were. No, it's not cube root. Why will it be cube root? Come on, the 2 was there. How can you miss that 2, everyone? I don't get it. How are you missing that 2? That 2 is also there, everyone. It's not cube root, Tanishq and everyone. It should be 2 by 3. The power should be 2 by 3. I don't know. It's 2 over there. Are you not noticing it, everyone? No, Vijay. It's ABC to the power 2 by 3. Are you all feeling confused with anything, whatever I've done so far? Everyone got it? With this, L'Hopital we have already discussed. I'll just discuss direct questions based on it. This one. X approaches 0. So I hope change in base we know. This I can write as ln of 10 square 2x divided by ln of 10 square, yes or no, where x is approaching 0. Remember that idea which we developed, everyone? Are you all there, listening, watching and understanding? So the best practice which I'd suggest here is that we know that, sir, if x approaches 0, this is 0. So 10, 0. I hope you remember the graph of log. This is how you see the graph of log. So if x approaches 0, log approaches infinity, minus infinity. So it will be minus infinity upon minus infinity, which is infinity by infinity. So the moment you deal with infinity by infinity, the best practice is L'Hopital. Everyone got it? Shall I bring L'Hopital here in this case? All the participants understood it. Sir, apart from L'Hopital, can we not use something else? Yes, you can, but I think L'Hopital makes complete sense. Why should we not use L'Hopital? One more thing you would have done is, that is, I think, not very much appreciated, but I'll do it that way as well. But let me do it with this way, with L'Hopital directly applied here. Infinity by infinity, it is Tanishq. It's not 0 by 0. So L'Hopital, if I apply, derivative of it will be ln of something is 1 upon. So it will be 1 upon 10 square 2x. And then as per chain rule, 10 square 2x derivative is 2. 10 2x. I think we are stretching it unnecessarily. Shall I keep it a little simpler? Should we really do it like this? I would avoid doing it because it will get stretched a lot. I mean, slightly. So other method could be, I hope you do get it, that first of all, I'll simplify these versions. Okay, no worries, bind up. At least you are there. We really appreciate it. Good. So good, Arvind. That's brilliant. So here I'll say that 10 squared 2x. I hope you do remember that 10 squared 2x. Forget this whole expression. Forget this whole expression. I'll just write it a little differently. This 10 squared 2x, can I divide it by, this is square. So if I divide it by 2x square, I hope you don't have any problems. So the problem is, should you not multiply it by 2x square? So I'll do it, don't worry. But now it is 10 2x upon 2x whole square. X approaches 0, 2x approaches 0, so 10 2x upon 2x approaches 1, so the square will be approaching 1. Getting it, everyone? So this whole thing can be substituted by 2x square. That's what my point was. 2x whole square. Similarly here, okay, one more thing I could have done. Why did I not do it? Anyways, now I'll do it. No worries. This 10x upon x. So to balance it out, I can replace it by x square. Remember that 10x, sin x and x are same when x approaches 0. So 10 square x can be replaced by x square. I forgot doing one thing. I don't know why. This square and square from here can be brought to the front. Square from here can be brought to the front. Square from here can be brought to the front. So they can be nullified. So I hope it looks better now. And this looks easy now. We can solve it very easily. Why? Because this is still infinity by infinity, but I'll differentiate it with a lot of ease now. I hope you're getting it. How? So if I differentiate it, this part, the numerator I can write as ln 2 plus ln x, and the denominator I'll write as ln x, where x is approaching 0. Getting it, everyone, without any confusion? I hope I'm not making any mistake. So when you differentiate it, ln x is 1 by x. This ln x derivative is 1 by x. Limit x approaches 0. So this should be 1. Is this answer 1? People are saying 1 by 2. Did I make any mistake? Shall I cross check it? Because I'm sensing that I made a mistake. Did I make any calculation based error? Let me just check it one more time. I'm sure we didn't, but still, if you think that I did, let me just cross check. I think I did. I may not have. So if I take this 2 first of all here, if I take this 2 here, so I hope this 2 and that 2 will get cancelled. So the next thing which I said was that 10 2x can be replaced by 2x. And next thing which I said was that 10x can be replaced by x if x is approaching 0. So the next thing which I did was, I think ln 2. I think the answer is 1. Everybody, did you all get it? Answer is 1. Answer is 1. Yes, because I can write it as ln 2 plus ln x divided by ln x, where x is approaching 0. तुमने पी? क्या? तुमने पी चाय? मैंने पी. Everyone understood this part, or are there still any confusions? Are you all there, watching, listening, and understanding? All the participants, yes or no? So with this, again, what I'm saying is, again, when 0, 0, minus infinity by minus infinity, so L'Hopital I'll apply. So 1 by x, that's cancelled, and 1 will be the answer. Everybody got this without any confusion. Next one. This one also, I'll say, can be done with the L'Hopital, but instead of using L'Hopital, you could have done series expansion. And with the series expansion, we have already discussed it, haven't we? I have told you or highlighted this, that this result you should memorize. I'm really sorry. I am messing up with something. No. This is sin x upon tan x. Do we have this? No, we don't have it. Okay, so I'll solve it. Anyways, don't worry. This is different. Different than what we have done. So where are we? This is where we are. Okay, so here we are. Pay attention, everyone. Sir, how do we solve it? Okay, Arvind got it. Vijay, just watch it again. I solved that question twice. So just watch that solution again. You will get it. Don't worry. All the participants getting so far? All the participants, any confusions or queries if you have, please ask. Then we have this question, the next one. It says x approaches 0, sin inverse x, tan inverse x upon x cube. So one of the maths, the best practice here would be use series expansion. So you can use series expansion to sin inverse, tan inverse as well. So here we are. Other ways is 0, 0, 0. So L'Hopital, but I can sense that L'Hopital will be used thrice. But let's see whether it gets simplified or it gets complicated. Sin inverse x. I will give you this question as homework. Just apply this thing. Differentiate numerator, differentiate denominator, and you'll get the answer. One method is hint number one, or approach one will be use L'Hopital. What could be the second method? Second method could be, hint number two will be use series expansion. I hope you know both of the methods, but preferably I'll suggest you to use this one. This one will be short, trust me. This one looks easy, but it would be lengthier. This one looks complicated, but it will be shorter. So will you try this question at home by yourself? Sir, how are we going to receive this PDF? The link to our free batch is given in the description. When you check the pinned comment or the description of this video, will take you to our free batch, where after logging into our free batch, you can access the complete batch at no cost. So these entire lectures, this entire series of one-shots of all your class 12 chapter, where after some time on this channel only, we'll start one-shot series for class 11 chapters as well. All the chapters of class 11th and 12th of PCM for JEE will get covered. With this, you'll get the PDFs and 24/7 doubt support as well. All your doubts at any time, anywhere will be resolved by us at no cost. That's our assurance. Few more cases, or the last question for the day, then continuity and differentiability I'm reserving for the next session. Is that okay? Let me see how much is left. If not much is left, I'll get it all done, but I think a lot is left. So I'll get all of that done in the next class. Is that okay? The last question for the day. Everyone with me so far? Any confusions? So where are we? Here we are, here we are, here we are. Yes. Final question for the day. Everyone, give it a try. Yes, Mohan, good evening. Tanishk, I'll get done a lot of PYQs in the next session. Let me get this entire chapter, limits, continuity, and differentiability done. Then I'll bring a lot of PYQs for you. So once I'm done with the complete theory, with illustrations, I'll bring PYQs of this entire chapter LCD. So part 1 is about to get over with this last question for the day. Part 2 will have continuity and differentiability, after which we'll do PYQs from LCD. Is that okay, Arvind and everyone? Okay, so pay attention everyone, here we are. How do we solve this? I'll say in this question, when x approaches 0 from right hand side, sin x also approaches 0 from right hand side, so some positive small values, log of some positive small values, that means log 0 minus infinity. So this is 0 to the power 0, because 1 upon infinity is 0. So this is 0 to the power 0. So how do we solve it? I'll suggest you a very simple method, that take it as y is equal to limit x approaches 0 from right hand side, x as base raised to the power 1 upon ln of sin x at base e. So if I take ln on both sides, so it will be ln of x, log of y at base e is equal to, this whole power will come to the front, so it will be limit x approaches 0 from right hand side. This will be 1 upon ln of sin x at base e, and this will be ln of x. So this will be what? Ln of x. This will be ln of x. Everybody got it, or are you still feeling confused? All the participants. Everybody with me so far. Any confusions or queries if you have, please ask. Otherwise, I'll move ahead. Everybody got it? Yes or no? All the participants. So I hope you all got the answer. Sir, how? I think you all, yes or no? That's good, Shubham. That's brilliant. Everybody. Yes. I repeat, how are you going to get the answer? Sir, when x approaches 0, from right or left, let's say right in this case, sin x and x are equivalent. So this sin x can simply be substituted by x, yes or no? So this is ln y, this is ln y at base e on the left. This is x approaching 0 from right hand side, x approaching 0 from right hand side. In the numerator, it is ln x. In the denominator, sin x can be substituted by x. So this is again ln x, because sin x and x are identical, near to 0, close to 0. That's good, Subhash. Ln x are getting cancelled, so it's 1. 1 is constant, nothing gets affected. So what I get was ln y at base b as 1. So I think y will be e to the power 1. That's your answer. So the answer to this question will be E. How many of you got E? That's good. That's good. Good, Shubhash. Good, Shubham. All the other participants, do you get E as the answer? So after this session, what are you supposed to do? After this session, we have done limits. We have still not done continuity and differentiability, which I'll bring in part 2. So in this limits, I have not done PYQs. If you want, you can, but you will be able to do it when continuity and differentiability are also merged. So PYQs I'll bring in the next session with continuity and differentiability. But you can solve some decent, good quality questions on solely on limits. So that's your task, that's your assignment, that's your homework. But if you want to revise all what we have discussed so far in this session, if you want to go through, so for your revision, this entire PDF you can avail by enrolling into our free batch. So where is the free batch? The link to our free batch is given in the pinned comment or in the description. You can check it out. Description, if you check, you'll get it. So Shubham is saying, sir, please give tips to study smart and get 200. For mocks, I think I have covered a strategy. The same video, Shubham, I'm constantly highlighting the same video if you watch this video. In the last part of this video, I have covered the mock analysis part as well. Trust me. Just watch this video. You will get it. It would be a significant achievement in my life. The dark way saying, I'm looking forward to hearing from you. Yes, same here. When is next session? In the next week. If you still want a suggestion from me to improve your score in mocks, I'll share a good strategy. Pay attention, everyone. We are not done yet. I'm sharing a very good strategy. I'm titling it as how to get the best out of your mock tests. Now, first of all, whenever you are attempting a mock, the first rule, attempt the mock in one attempt. Which means, let's say the mock is of 3 hours. You don't split it into 1 hour or you take breaks. You just sit for 3 hours straight and attempt it. Second rule, once you have attempted, yes, analyze. Now, sir, everybody says analyze the mock. How? So analysis means you go through the questions you have marked correctly. Sir, why? I have marked those questions correctly. Why do I have to go through those questions? Because when you analyze those questions which you have marked correctly, you may find some better approaches, some better methods, some better solutions. So if you could find some better solutions, it will help you in saving your time next time when you see something like that. Okay, sir. The questions which you have marked correctly should be analyzed. The questions which you have marked incorrectly, those are to be analyzed. So there, look for the error. Now, error are of 2 types technically. Rather, I'll say 3, but still 2 types. One is calculation-based error. So that is called a silly error. You cannot do much about it. It could have been done because of some panic or some mistake, or that even I do at this stage. So that's natural. But let's say if it is not calculation-based silly error, then in that case, what else it could be? It could be a conceptual error. So what do you mean by conceptual error? Conceptual errors are those dark spaces which are the zones which you should be aware of, which means if you realize that I applied a wrong formula, I applied a wrong expansion, I applied the wrong stuff here. So go to that chapter, don't revise the whole chapter, just revise that concept. So whenever you make a conceptual error mistake, revise that concept. Instead of revising the whole chapter, revise that concept only. Now, so there are 3 questions. One we have marked correctly, one we have marked incorrectly, and the third category of questions which you skipped. In that skip, you will find 2 categories. One which you skipped were actually easy, but you assumed them to be more tough, and the ones which were actually hard. So appreciate yourself if you skip the harder ones, but you need to look for this, that if you are skipping the easier ones which were supposed to be done by you, why did you really skip those? So these ones which you found to be easy, which you found to be hard, which were actually easy, should be noticed by you, that why did you find them to be hard. So if you found them to be hard, now what you do is, the next thing is that if easy questions are looking hard to you, the only mistake you're committing is you're weak at those areas. You're weak at those areas. So what are you supposed to do? Again, simply revise. Revise means what? Revise that whole chapter? No. Revise that whole chapter? No. No. Revise that whole topic? Yes. That simple topic which you're finding tough or difficult, just go through that topic. That's how you get the best out of it. How to judge? That judgment comes with practice. Shubham, the more mocks you attempt, the more better judgment you'll be able to bring. And I think that's exactly the zone. Sometimes harder ones you skip, appreciate yourself, but sometimes you assume easier ones to be harder ones and then you skip. Why does it happen? Because you just don't know that concept. So if you don't know anything, even an easy thing will look tough to you. So that will become easy with the time if you keep revising that concept. Simple, Shubham. So it comes with time. That judgment comes with time. I think I have answered that query. Any other concerns or queries if you have, please ask. Otherwise, we'll call it a day. Yes, Dark Way, I am also looking forward to hearing from you. But how do I hear it? Can you avoid using this AI generated answer here in this chat? Shubha says I've answered. The next session is in the next week. You will be informed. So are we done? Any other queries or concerns if you have, please ask. Otherwise, we'll call it today. Everyone, can we call it today? Thank you so much. Thank you so much. It was really nice interacting with you all, Vijay, Shubham, everyone who all were there. It was really nice. So keep it up. Keep showing up. We'll do continuity and differentiability and a lot of PYQs from this chapter, limits, continuity and differentiability, in the next session. Thank you so much, everyone. Take a good care of yourself. Good night. Good night, everyone.